When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqf can bless our community with a legacy of care.
A warm welcome to one and all. Welcome to the Awqaf SA Maths Workshop. Today we'll be focusing on Maths Paper 2. Mr. Khota will be taking you through trigonometry, analytics, and Euclidean, among others. This workshop is hosted by Awqaf South Africa in association with the Department of Basic Education, the Kway Institute, iSkills, and we're coming to you live from South Peninsula High School in Plumstead, Cape Town. Goeiemorgen, good morning, Sawubona, Namaste, a warm welcome to one and all, and Assalamu alaikum wa rahmatullahi wa barakatuh. We welcome all our online audience from KwaZulu-Natal, Gauteng, Bloemfontein, Pretoria, and beyond. Let us know in the comments from which school you are coming to us from, which province. Please let us know in the comments, and please let us ensure that this is an interactive session. Please do give this video a like. It is our intention to reach 10,000 subscribers by the end of May. So please, all participants that's logging on during the session and post-event, please do us a favor and do subscribe to our YouTube platform. We are streaming this live via Awqaf's YouTube platform, Facebook platform, as well as X for the first time. My name is Hassanin Abdullah, and I'm from Awqaf South Africa, the organization that is hosting this workshop. And we are a community organization focused on uplifting our communities. We achieve this through the borehole projects that we are involved with. We do have some interventions around health, youth leadership, and this project is our contribution towards providing quality education in South Africa. So we've been doing this since 2015, and the aim of this program is to assist learners who are struggling with mathematics, and also to assist some of the learners that do have academic potential by assisting them to reach their full potential. So we do have Mr. Khota. He'll be the facilitator of the session today. These videos are hosted on Awqaf's website, awqafsa.org.za. So you can refer back to these videos and use this during your revision leading up to the final examination. I'm going to be calling on Mr. Baker, the principal of South Peninsula High School. He'll say a few words, and thereafter we do have one of the educators from South Peninsula, Mr. Adnan. Mr. Baker?
Thank you, Hasnain. Warm welcome to everybody in the room here this morning, and also to all the students who are live streaming wherever you are in South Africa. Welcome to day 2 of our maths program, and I want to take this opportunity also to thank Awqaf for arranging the maths tuition program for all the students in South Africa. Long may this continue. Also to an amazing maths teacher who we are privileged to have with us here this morning, Mr. Khota. I'm sure that the students who live streamed yesterday, as well as the students who were here in person, they must have thoroughly enjoyed the session with you. And today, I know it's a section of the work, and with my limited knowledge of maths, it's a section of the work that many students battle with. And so I'm sure that at the end of today, you should have a better understanding about that. On my left-hand side here, I have a respected person in the maths fraternity, in Adnan Idris. He's also a chief marker for maths paper 1, but he is our head of maths, and I'm sure he will also have a few words just to say to you. But before I hand over the mic to Adnan, students, I didn't sleep well, and I'll tell you why I didn't sleep well. I was worried as to how many students would be here live today, and I must say I am extremely humbled, and I'm impressed with the turnout for today's session. And I'm sure that the students who were yesterday, they must have spread the word to the other students. So well done to the students who are here today. You deserve a round of applause for that. And I want to say, students, yesterday it was the open day of UCT. Last week, or 2 weeks ago, it was the open day of Stellenbosch University. Next week, it's the open day of UWC and CPUT. Now, these are all tertiary institutions, and I'm sure this is happening throughout the country. The universities, the tertiary institutions are trying to woo our matrics to apply to those institutions. I want to say this, students, it starts here. If you are doing well in maths, if you are scoring above 50% in maths, then in my opinion, you are guaranteed an entry to university. And we know the importance of education. We know how important it is because you are the future. You are the next leaders of our country. We are a developing country. We need you to be educated. We need you to grasp every opportunity that you have to further your education so that you can serve your community. And so I wish you well for today. Yesterday it was 7 hours. and the students who live streamed, the comments that Mr. Khota referred to, the students who were present also here yesterday. Yes, it was tough, but you persevered. And that is what we expect from you today. Without further ado, I'm just going to hand over to Adnan Idris.
Good morning, students. It's always difficult speaking second. As I said, Mr. Baker said quite a lot of what I wanted to say. So I'm going to start with something just totally different. This reminds me of one of those music concerts. When you sell out tickets, those of you who go to Taylor Swift, let's call you Swifties. So we could refer you today as Coaties. So I hope that you enjoy today's session. Mr. Baker has outlined the importance of math. I cannot stress that even more than what he has done. And it's absolutely correct. If you speak to any grade 11 or 12 student and you ask them, what is the sections that you really, really struggle with? They will say it's paper 2. You are in grade 10. And this is therefore the foundation where you actually lay down a solid foundation so that when you get to grade 11 and you get to grade 12, you will find it so much easier. And that is why we appreciate all of you attending, those of you who sacrifice, as Mr. Baker mentioned, those people that are logged in online, that stood up early to make sure that they are connected today. And I hope all of you, and this is the most important thing, all of you remember what is said today. So write as many notes as you can, remember the notes, because it's no point sitting here today and then in a week's time when you actually write the exam, you had forgotten everything that was said to you. So please, I hope you enjoy yourselves. I know that you will because of yesterday. In fact, we have more people. Now we're finding where should we put the more seats. But I hope you all enjoy today. Thanks so much.
Thank you so much.
So thank you to Adnan for that encouraging words. And yes, we had a competition last year to award academic excellence, and we will extend it this year also. And we really hope that from this competition that caters for grade 10, 11, and 12, we really hope that from this cohort will be winning the top prizes. So we award cash prizes to the top performing learners. We normally open up this competition in January, so it will be in the new year. So look out for that. There will be some communication from the school as well as our online audience. Please do subscribe to our social networks at Awqaf on Instagram and on Facebook, so you won't miss out when we do put that call out for the competition. So we want to incentivize and award you for working hard at your work, right? And we need more engineers, more scientists, more accountants, some great minds that we can really push this country forward. So enough talking from me. I'm going to be in the background today. Mr. Khota is going to be the man in true effect today. Mr. Khota is the driving force behind the Kway Institute. He assists learners with the mathematics. So maths is what he does 24/7, and he's been also a very important part of Awqaf's intervention. We've been doing this since 2016. So to call on Mr. Khota, I'm going to try and log in Mr. Khota's launch sequence. So let's try and see if we can get this video going.
And a bit of an echo there, guys. Huh? Give me a second. No, it's on mute. I did. Is your mic off? Now it's off. Okay, here we go, here we go, here we go. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, good morning, good morning to our on-siters, bums on seat and eyeballs on screen. So good morning to everybody. I hope you guys, hello South Africa. I see Layla is in, Mango Fish. I'm looking at all the comments are hilarious. Who's Mango Fish? Is Mango Fish here in the house here? Oh no. Okay, but anyway, yeah, hi guys. I'm looking at all the amazing comments that are coming through. People are talking about Taylor Swift and the Swifties and the Coaties and the Bugattis. And what color is your Bugatti? Well, we are not top G today. Today we are top K. We are Coaties. Right. Andrew must be watching this from wherever he is, somewhere in Romania. Right. Welcome, 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 everybody. Let's get, yes, you all dreamt about math last night. So, yeah, welcome, everybody. Guys, another bumper session today. It's truly heartwarming to see everybody was here up early in the morning. And some of them said they were up at 7 this morning. Some of them didn't sleep. Some of them had nightmares about me. Some of them saw me chasing them with X's and Y's in their sleep last night. So they dreamt about math last night. That's a good sign. Good morning, good morning. I hope you're bright and fresh and early with your coffee and sisters on a Sunday morning. Welcome to Club Khota, Club K-Way, Club Math. Right, taking you through until the end of today. So boys and girls, let's get started. What's required? Your scientific calculator, writing pad, stationery, and all your hydration and refreshments for today. Let's get started. Okay, guys. Energy all the way. We are boosting on math. I know we had a bumper session yesterday. It was the first time that you guys got introduced to us yesterday. And I think it took a little bit of time. It took the whole first session for you guys to get warmed up. Well, now that you are all on fire, let's kick into day 2. So let's get our whiteboard up. Welcome back for the grand finale for today. Let's clear the frame. Take out your books. Brace yourself. Strap yourself up. Let's quickly go through a revision of yesterday where they told you solve for X. Take this down. I'm just doing a recap of yesterday where we ended up. So they tell you 2x squared minus 5x is equal to 3. And this one came out of the KZN past paper. Solve for X. Right, let's go, let's go. We got a big session today. I'm finishing up with the algebra, some equations, simultaneous equations. We'll do analytics. We'll go into trigonometry. I know many of you haven't done it. I'd love you guys all to stay in for it because I assume that you all know nothing. And we're going to take you through the whole of trigs. You're going to love trigs. In fact, trigs is a topic you're going to look for in your exam to score marks. Thumbs up. Thumbs up. Here we go. Here we go. Here we go. Guys, brilliant seeing all of you. Thank you all. Onliners, lots of love from K-Way and Awqaf. Let's get started. Okay, so we got 2x squared. I told you whenever there's a square, the right-hand side must be 0. So minus 5x minus 3 is equal to 0. Yes or no? According to yesterday. If you weren't here yesterday, please go to the Awqaf website and watch yesterday's session. Right. What do we do now? What method? Snotkop. So let's draw the eyes. So those of you who weren't here yesterday. So there we go. 2 and 3. The first and the last are the eyes. There's the nose. There's the mouth. In the mouth is minus 5. So we need the tears. We cross multiply to get the snot. And the snot drips in the mouth. Right, so let's go. Give me 2 factors of 2. 2 and 1. Give me 2 factors of 3. Shh, quiet. Thank you. We're going to go, let's try 3 and 1. Let's be stupid. Let's be stupid. So 2 times 1 is 2. 1 times 3 is 3. Can a 2 and a 3 give me a negative 5? Yes, it can. Shh, listen. This must be minus 2, minus 3 to give me minus 5. But wait. Negative times negative is what? And what's my last sign? So are we right or are we wrong? We're wrong, right? So that means instead of, and I'm glad they gave this one. This is straight out of a past paper, guys. And this is end of the year. This is a final exam grade 10 question. So instead of 3 and 1, let's swap it over. Let's make it 1 and 3. 2 times 3 is 6. 1 times 1 is 1. Can a 6 and a 1 also give me a 5? Yes. Yes. We say, you know, we Joe Burgers, we flat. We say yes. Ne. You guys say nah? Minus 6 plus 1 will give me negative 5. And negative times a positive is a negative. So now we don't think we're right. We know we're right. So here we go. There's our brackets. 2, 1, 1, 3. Watch here. So those of you who weren't here yesterday, let's go in. First bracket, 2, 1. So eyes, nose, mouth, the 2 tears, cross multiply to get the snot. Right. Right. So 2, 1, 1, 3. There we go. 2, 1, 1, 3. Your 2 brackets. We put x and x to get x squared. Now we start from the 2 next to each other. 1 times 1 is how much? 1. What do I need? Positive. 3 times 2 is how much? 6. What do I need? Negative. Game over. Now we need to solve for x in each factor. So we got 2x plus 1 equals 0, first factor. Remember, your right-hand side must be 0. You cannot have a constant on that side. If you got a constant, take it over. And x minus 3 equal to 0. Let's solve for x here. 2x is equal to minus 1. Divide by 2 on both sides. Minus 1 over 2, or x is equal to 3. Problem solved. You got yourself 5 marks. Lekker ne? Kwai. And there we go. There we go. There we go. Hello, Dayan. Hello, Mango Fish. Spectral Pal. Suraya. Okay, okay, okay.
They're asking why the rocket ship? Why the launch?
Because you are now launched into the orbit of mathematics. You are now in the galaxy of mathematics. You are now on the planet of mathematics. I was going to say something, but this is a parental guidance show. Let me keep quiet. It's PG. It's PG. Let me keep quiet. I'm going to get wrapped on my knuckles for comments. Right, here goes. Here goes. Here goes. Here goes. So we're done with that. Let's give you one where we ended up yesterday as well with the exponential equations where we had to make the basis the same. Let's see if you guys can do one of that. Also from a past paper. Yeah, planet rule. No, planet Uranus. No, I'm joking. All right, let's go. We're clearing. We are clearing. We are clearing. Let's go. Solve for x1. Luckily, Hassanin didn't hear that. He's busy with something else. Anyway, let's go, let's go, let's go. Right. Solve for x, guys. Solve for x. It's so wonderful to have you all here. All the onliners, all the bums on seat. On a Sunday, one big study group doing math. Inshallah, I should see you guys again in September to prep you for September. And at the end of the year, 2-day workshop, where in 2 days we'll cover the whole year's work with all past papers. So basically, it will be one big lekker study group. The whole of South Africa. This was my dream 20 years ago, and it's a dream come true to be able to tutor thousands and thousands. 2 years or 3 years ago, we had over 300,000 grade 12s, all in one study session. And that's how we produce distinctions, right? Let's go. Right, guys. Let's start. Let's start. Shh. Now we've got to make the bases the same. I told you yesterday what base, either a 2 or a 3 or a 5. You got to use prime bases. So there is a 2, so I'm going to leave that. Watch here. For those of you who weren't here yesterday, that's 2 to the minus 1. We bring that up. to the power 3x minus 1 is equal to, we know by now, 128 is 2 to the power 7. Guys, in grade 10, you ought to know from 2 cubed is 8, 2 to the power 4 is 16, 2 to the 5, 32, 2 to the 6, 64, 2 to the 7, 128, 2 to the 8, 256, 2 to the 9, 512, 2 to the 10, 1024. Those are your most commonly used ones. Know them like you know your timetables. Now, remove the brackets. So that's 2 to the minus 3x plus 1. Remember, we multiplied by both. Shower the power. 2 to the power 7. Now cancel the bases. Let's solve for x. Minus 3x plus 1 is equal to 7. Minus 3x is equal to 7 minus 1 is 6. Divide by negative 3. Divide by negative 3. Bada bing, bada boom. Your final answer, moment of truth. Positive divided by negative is a negative. 6 divided by 3 is 2. Let's see how many of our onliners got that one right. Did anybody? Negative 2, Rami. Well done. You get a star for that, brah. Well done, well done, well done. Mike, you got it right. Well done. Hey, welcome, Mike. Mike, hey. How's it, Mike? Hey. Let's go. Nabila is in. Kosinati is in. Well done, well done, well done. Remember, it doesn't matter where you are from the country. Chat to us in our comments so that we can connect with you personally. Doesn't mean that we are online. You're just a statistic. You're not. You're not just a stat. We want to talk to you. We want to know who you are. And hopefully when we're in your area, you can come through and say hi, like so many of the Cape Town learners here at South Peninsula on this beautiful Sunday morning. All right, let's go. That was done. Shh. Let's go into now. We didn't do simultaneous equations, so they end up the topic with the simultaneous. Please, you need to learn how to do it. We're going to do it by substitution. So they don't tell you by which way to do it. They just say solve for x and y. Solve for x and y. Let's go. I'm taking the one straight out of the past paper. The past paper that we're using is KZN. KZN 2023. Grade 10s, by now, you should be downloading all your past papers from NSC, from the site. NSC past papers, grade 10, national past papers with memos. See the structure and work through the problems. 4y plus 3x is equal to 9. Okay. Now we call this one equation number 1. We call that one equation number 2. Now many people say this is simultaneous equations. Now you can add, subtract, multiply, divide, or you can substitute. The choice is yours. Have fun. 2 equations. It's the same x. It's the same y. Right. Many of you say, listen. Many of you say that you got to study math to understand math. You can't study. You will fail. You can't study math. You got to understand math. And to do that, I can prove it to you mathematically. If you guys say you study, you won't fail. So that's what you say. You say study, you won't fail. So therefore, the opposite, no study, according to you, will equal to what? Fail. Let's call this equation number 1. And let's call that equation number 2. Let's add the 2 equations and let's solve simultaneously. So we have no study plus study on the left is equal to no fail plus fail. Now we got 2 terms. Yesterday we did the highest common factor. Let's factorize. What's common here? Study. What's left over? No plus study divided by study is 1. On this side, what's my highest common factor? Fail. What's left over? No plus 1. Let's divide this side by no plus 1. What I do on the left, I do on the right. We have just now proved that if you study, you will fail. Right. So don't study. You got to understand. You got to enjoy. You got to process mathematics. You got to understand the processes and procedures. You can't study math. Once you have math, you have math. You have it for life. It's like I teach you I ask you what is 2 times 3. You just give it to me. You say 6. Why? Do you need to physically count it? No, you've done it so much. You've processed it. You can't study 2 times 3. You got to know it. The same thing here, guys. Shh. The same thing here. Let's do it. I would say let's take equation number 1. In equation number 1, let's put it in terms of y. So 2x minus y is equal to 17. I'm going to do it by substitution. I love substitution. It's so much easier. Right. Pay attention. Now we want it in terms of y. So minus y is equal to 17 minus 2x. So divide by -1. So y equals divide by negative. So all your signs will change. So we left with 2x minus 17. There we go. So y is equal to 2x minus 17. Right. Here goes, guys. Right, let's start. So now we're going to substitute. We were working in equation number 1. We now substitute 2x minus 17 for every y, that's what you're saying, in equation number 2. So now we're going to equation number 2. For, instead of y, 2x minus 17 plus 3x is equal to 9. I'm going to put a tick there. Does everybody understand that? Easy. We took the first equation, we put it in terms of x or y. We take that and we plug it into, we substitute it into the opposite equation. And now it becomes an equation. Just solve, guys. Just solve. So we multiply out, we're going to get 8x minus, what is 17 times 4? 17 times 2 is 34, 68. Plus 3x is equal to 9. 8x plus 3x is 11x. 9 plus 68, I'm just going to write it out for you. 11x is equal to, what is 68 plus 9? 77. Divide by 11, x is equal to 77, divide by 11 is 7. Please, guys, don't ask me now, you're in grade 10. Don't ask me, sir, how did you get 7? We divided by 11. You are grade 12s now. You are 10 to 12, you are already grade 12s. So stop thinking grade 9. Start thinking 10 to 12. You are no longer babies. Right, let's go. We solve for x. Now we substitute this back into the original to get y. We put that one back into there. Now we say substitute 7 for x in, you could have called this one equation number 3 if you want to. So we got y is equal to 2x minus 17. Y equals 2 into 2 times 7. Please use brackets. Y is equal to 2 times 7 is how much? 14. 14 minus 17 is how much? -3. There we go. X is equal to 7. X is equal to 7. Y is equal to -3. Listening? Listening? You want to tell him just to drop the volume slightly from that side. The mic volume, just to drop it slightly. There we go. X is equal to 7. Y is equal to -3. Let's see our onliners. Who got that one right? Let's go through our comments there. Anybody got it right? No, nobody even typed in. Guys, wake up. Mikey got it. Lovely, lovely. Let's give you. Thank you. There we go. Here we go. Here we go. Do you guys want one more to do? You want to try one like this on your own? You you want to start with any equation and put it in terms of x or y. Then substitute it in the opposite equation, get a value, put it back into the first equation, and solve for the opposite value. Let's give you one more. Those of you who have taken this one down, let's make it a bit rough. Come, here we go. Let's make up one. You might get fractions here, guys. You might get fractions here. Watch here. 2x minus 3y is equal to 8. 5x plus 9y is equal to 40. Right, have fun. Solve for x and y. Solve for x. This one here, you're going to have fractions. This one, we're going to be dealing with fractions. Onliners, come on, wakey, wakey. Get those brains moving. Get those brains working. Thank you, grade 10s. After this, I'm going to give you some equations with fractions, and then changing the subject of the formula, very important, and then we will go into analytics. So guys, like we told you yesterday, before you know it, we're already into break time, and before you know it, today is over. So if you stay focused, we good. If you stay focused, we good. Thank you, Tamana. Thank you, Shadley. How's it, Shadley? Welcome back. Samia Khan, you got it. Fayad, glad you're enjoying it. Zonke, Isabella is in. Tina is in. Right, here's one to do on your own. Let's see who's a boss. Who's a legend? Math legend. Top K. So let's just for explanation, right? So we're going to call that one equation 1, equation 2. Let's all do it in one way. Let's all start with equation 1 and let's put it all in terms of x. So it makes it easier when I'm doing so. I don't need to do 4 different memos. Let's all start with equation number 1. Start with equation number 1 and put it in terms of x. Let's all do it together. Right, go for it. I'll give you a couple of seconds. Here we go. Dayan is still half awake. Dayan, wake up, brah. Be fully awake. You got to be fully engaged. Imagine your network on your phone was only on half power. You think you're going to get any downloading done? You need to be operating on 5G. Wash your face, get your calculators out. Be wide awake, guys. Such an amazing opportunity for the learners here to connect with each other as well as on a live chat. They're actually becoming family. And some of them said yesterday they want to open up a WhatsApp group or whatever the case may be. Amazing.
They want to open up a math shop.
They want to open up a math shop. Right, let's go. Equation number 1, 2x minus 3y is equal to 8. 2x is equal to 8 plus 3y or 3y plus 8. X is equal to 3y plus 8 all over 2. Right? We're dividing by 2. Right. Shh, quiet. That's equation number 1. Now we substitute 3y plus 8 all over 2 for x in equation number 2. So now 5. What does equation number 2 look like? So we got 5. For every x, what must I put? 3y plus 8 over 2. 3y plus 8 over 2 plus 9y is equal to 40. Be careful now. We need to get rid of that 2. What's the opposite of division? So we multiply this first term by 2 to get rid of that 2. What I do to one term, I got to do to all terms. So what am I left with? 5 times 3y is 15y. Plus 5 times 8 is 40, plus 9 times 2 is 18y, is equal to 40 times 2 is 80. Boom. I hope you all got that. Then you are in trouble. You need to go home and you need to practice. Today is about understanding. Practicing will take place at home. Here goes. 15 plus 18 is 33y is equal to 80 minus 40 is 40. Y equals 40 over 33. Let's see from our onliners how many of them got that one right. 40 over 33. Let's see. Did I get to a... Hey, Trace, well done. Mango Fish, you moving on 2G, brah. You're going to be logging off just now. You're going to DC any second. 5G unlocked, Tamana. That's it. Nabila, well done. Mango Fish, 40. Hey, Mango Fish is on fire, brah. Havish Mudli realized his mistake. Don't mess it up. Now we substitute. We were working in equation number 2. We go back into equation number 1 or equation number 3. If you wanted to, you can call it equation number 3. We're now going to say substitute 40 over 33 for every y in equation number 3. What does equation number 3 look like? X is equal to 3y. Y is 40 over 33 plus 8 all over 2. X is equal to, go to your calculators, guys. As long as you don't give your answer in decimals, you quite. So 3, open brackets, fraction, 40 over 33, close brackets, plus 8 equals, let's divide that by 2, equals 64 over 11. Well done to those of you who got it right.
Question.
Here we go. Geometry we're doing last. We still got analytics. We still got trigs. We do geometry, and if we have enough time, we do functions last. 40. Come on. 80 minus 40. 80 minus 40. Damien, come on. Wakey. 80 plus 40 comes on that side as minus 40. 80 minus 40 is 40. Wakey. Hope that answers your question, Damien. Right. Here goes. Shh. Quiet. Right. Quiet. Right. Let's give you an algebraic equation, an equation with unknowns in the denominator. This is where we're wrapping up. Algebra, and we're going to move into analytics. Paper 2. Right, here goes. Right. Let's go. Guys, keep your comments to math. Dayan, keep your comments to math. Let's see how we can crack this, guys. I'm clearing the frame. I hope you took this down. You'll continue at the bottom. I'm just moving to the side because of space on my screen. Are we all okay? Grade 10s, we good? Who's still writing? Nobody. Good. Excellent. I'm clearing the frame, guys. Right. Shh. Let's start with this one. Watch here. Solve for x. Pay attention to this. So it's an equation. 7x over x squared plus x minus 5 over x is equal to 3 over x plus 1 for 6 marks. 6 marks, solve for x. Right. Onliners. Right. Here we go. Quiet. Thank you. Now, I'm going to show you quite a different way to the way you've been taught at school. I can show you how to get rid of all these denominators in one step. So pay attention. That's a question. Here's your answer. So let's factorize. Make sure you factorize the denominator. 7x over x into x plus 1, highest common factor, minus 5 over x is equal to 3 over x plus 1. So let's put a tick there. You understood what I did there. The only thing I did there was highest common factor. Yes or no? Right. Put down your pens. Right. Here goes. Shh. Guys, Onliners, you need to pay attention here. You need to pay attention here. You need to pay attention. Because you're going to ask me to redo it and I'm not. Right. We want one multiplier. We want one multiplier, a common multiplier that we are going to multiply each term by to get rid of each denominator. So it's like a LCD, but we're calling it a common multiplier. So we choose an x because there's an x. So I'm going to multiply this by x. I'm also going to multiply it by, so it's x into x plus 1. I'm going to multiply this. Now watch. There's an x, I got an x, so I don't need to attach another x. There's x plus 1, I got an x plus 1. So I'm just going to multiply every term by x into x plus 1. Watch here. And see how nice this is. This would have been an LCD, but I'm calling it a common multiplier. Now, see how nice is this. Just watch how quiet is this. That whole thing and that whole thing will cancel. What are you left with? 7x minus x and x will cancel. 5 times x plus 1. 5 times x plus 1 is equal to x plus 1 will cancel. X times 3 is what? Game over. We now can solve for x. All denominators are gone. All done in one step. You don't need to find LCD, multiply both sides. No. You take that LCD that you were going to find and you multiply every term by, but you can only do this in an equation. And you get rid of all denominators in one step. So take this one down. I will do one more like this afterwards. Take this one down. Take this one down. I hope you guys are enjoying this. It's going to save you so much of time in the exam. It's going to save you so much of time in the exam. And guys, if you missed something, like I said, these sessions are recorded immediately after the session on the Awqaf website. You can just click, these sessions are recorded. You can watch it over and over and over. Right, let's solve for x now. We're not yet done. So 7x minus 5x minus 5 is equal to 3x. 7x minus 5x is 2x. Plus 3x will be minus 3x. Minus 5 will come on that side as plus 5. Remember, you want to collect your unknowns on the one side, knowns on the other side. Don't forget to change over the signs when you're carrying it over your equal to sign. So 2 minus 3 is minus 1x is equal to 5. Divide by negative 1, divide by negative 1. Here's your final answer. X is equal to positive, divide by negative is a negative. 5 over 1 is 5. Your answer is negative 5. There we go, Havish. Well done. Well done. Well done, Havish. I can see you are focused and I can see you are learning. Well done. I'm going to give you guys one more like this to do. You'll apply this no matter what situation you're given in an equation with unknowns in the denominator. You find a common multiplier and you multiply everything. You get rid of that common denominator. Please practice. Master all these systems and we'll be good to go for the exam. It's very easy to get 100% in math. You just got to know what you're doing. And don't make a mistake in your algebra. Right. For those of you who have taken it down, let's start you off with the next one already. No, it's fine. I know some of you are still writing here, but some of you are faster than others. I don't want to waste your time. Let's go. 2x plus 1 over x minus 5x over x squared minus 4x is equal to 2. For 6 marks, solve for x. Those of you who are done, you can already start with the next one. Have fun. Knock it out. And feel like the top K when you are done. Right, let's go. Let's go. Right. Now, guys, if you guys going to go on crazy on the chat line, in the chat box, and you're going to say stupid things, they're going to put you on timeout. They're going to put you in a detention room. They're gonna time you out for about 15, 20 minutes, maybe half an hour if you do it at the first time. The second time, they'll do it a little longer. And then finally, on the third time, they say, Salamu alaikum. Goodbye. Okay. Let's go. Let's go. Let's go. Let's go. As long as the learners are engaging with us, we're talking to them, we're seeing Havish, Trace, Mr. Ravi, Universal Astronomer, Anam. Everybody's getting -1. Okay. -1 going once, -1 going twice. Sold at -1. Is -1 your answer? I don't know. Let's check. Let's check. Find the common multiplier. Let's go. Let's go. Right. So we're going to multiply everything by x. We're going to multiply everything by x. And this here is going to be x into x minus 4. So I'm going to multiply everything by x into x minus 4. Right, so here goes. X and x will cancel. I'm left with x minus 4 times 2x plus 1. That's what was left over. Minus, I'm going to multiply this by x into x minus 4. So that and that will cancel out. We're only left with 5x. And don't forget, we got to multiply the 2 also by x into x minus 4. Let's multiply this also by x into x minus 4. You must factorize it. Don't multiply it in its compound form. Multiply it in its factorized form. So 2 times x is 2x into x minus 4. There we go. Let's remove the brackets. Let's FOIL it out. 2x squared. That's my 2 first. My 2 outer plus x. My 2 inner minus 8x. My 2 last minus 4. Minus 5 is equal to 2x squared minus 8x. Right. So now, let's see. 2x squared plus x minus 8x minus 4 minus 5 minus 2x squared plus 8x equals 0. Yes. There we go. 5x. Thank you. Thank you. Luckily, we picked that up there. Astaghfirullah. Astaghs. Hashtags. Let's go. Right. 5x. We forgot the x. It's okay in life. Forget about your x. No. You don't do that in math. You don't do that in math. Right. Let's go. 2x squared minus 2x squared, gone. 1x minus 8x minus 7x. Or you can say minus 8x plus 8x is 0. We're left with x minus 5x minus 4x. And then we got minus 4. Minus 4 is the only thing we have. Is equal to 0. Take that on the other side. Minus 4x is equal to 4. Divide by negative 4. Divide by negative 4. And yes, you guys were right. Your answer is -1. Well done, onliners. Well done, onliners. -1 is the answer. Yes. Specificle. Kakaza. I hope I pronounced that right. Specificle. Kakaza. Kwezi, -1. Well done, well done, well done, guys. Well done. Okay. So for those of you who didn't get it right, take this one down. We multiplied every term by a common multiplier, got rid of all the denominators, and we are sorted. Right. We are starting now with paper 2, analytics, guys. Let's get into paper 2, analytics, a big topic, easy marks. Easy marks. We're starting with paper 2, analytics. Let's get started. Let's get started. Before you know it, we are into break. By the time we're done with analytics, you're into break. You come back, we're going to start with trigonometry. Right, so let's go. I hope you all got this down. All part of yesterday's notes. You're rewriting your own study guide, so you need to know what you are doing. Thank you, grade 10s. Thank you, thank you, thank you. Right. Analytics used to be called analytical geometry. It's paper 2. Right. We deal here with a Cartesian plane. And we only deal with 2 coordinates at a time. We only deal with 2 pairs of coordinates at a time. Now, you all know what is coordinates. If I told you, remember in a pair of coordinates, that's also called an ordered pair. X comes first, Y comes second, always. You never get Y first and X second, all right? No problem, you guys can eat. No stress, eat, drink, suck your lollipop, chew chappies. We good. We quiet, no problem. You working here, brah. We just one big study group. Even if you had a piece of pizza here, slan it. Kimba. Right, here goes. Shh. Right, pay attention. So, we only need to know a certain set of formulas. The first formula we need to know is our distance formula. The length between lines or between 2 points. So let's talk about the distance between, let's see, A and B. Watch here. So all I'm going to do on the side here, I'm just going to draw a quick rough Cartesian plane. Quiet, guys. That's 0. That's your x-axis. That's your y-axis. And let's give you a point here. Let's say that point is A, 4, and 10. And let's give this point here B. Let's just call it point B. Now, in most cases, you'll be dealing with a triangle or rhombus or parallelogram. Please pay attention. And let's say that's -6 and 2. Here goes. So we need to know the distance between the 2 points. Right. How would you, they'll ask you. That is why it's so easy. It's worth 20 marks in your exam. It's marks you don't want to throw away. And you'll be doing it in grade 10, 11, and 12. Data handling will be question number 1. Analytics is always question number 2 in your, according to the format of your paper, paper 2. Pay attention. The distance formula, guys, please memorize these formulas. Between A and B is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So you can call anyone, let's call that x2, y2. You can call that one x1, y1. Or you could call this one x2, y2, x1, y1. No problem, you'll get the same answer always. Okay? Right. Memorize these formulas. So the first formula you need to know is your distance formula for the length of a line. Why? You might need to prove a shape. You might need to prove that it's a square. That means you'll have to calculate all 4 distances must be the same. Prove it to be an isosceles triangle. So 2 sides' lengths must be the same. Number 2, the next most important formula is your gradient formula, the slope. So we call it the M of AB. The gradient, what is the gradient? It's represented as a fraction. So we all know it's change in y over change in x, but when we are given 2 pairs of coordinates, it's always y2 minus y1 over x2 minus x1. Right. Why is the gradient formula important? When do we need it? This is important work, guys. This is important work. This is important work. This is important work. You're going to need it for grade 11 and 12. 10, 11, and 12. You master it now. You sort it for the next 2 years. You mess it up now, you'll suffer throughout. Pay attention. Thank you. Yes, don't worry, we're getting to all the formulas. Let's not put the cart before the horse. Let's go through it formula for formula. Right, here goes. When do we use the gradient formula? Obviously, we use it when we want to find the equation of a line. If the question says find the equation of the line, so we need the gradient, the equation of a line. And we know the equation of a line is given by y equals mx plus c. Yes or no? Right. Pay attention, don't write. When else do you use the gradient formula? You use the gradient formula for parallel lines. When you need to prove that two lines are parallel. That means, what is the rule for parallel lines? What is the relationship between gradients of parallel lines? The gradient of line 1 must equal to. Can you see an equal to sign is parallel? Can you see? An equal to sign is parallel. So it will help you to remember that for parallel lines, the gradients must be equal. So the gradient of line 1 must equal to the gradient of line 2. Right, very important this, guys. I need your full attention here. Jokes aside. Now, 90-degree lines or perpendicular. That sign is perpendicular lines. The m of line 1 multiplied by the m of line 2 must equal to -1. The product of the gradients must equal to -1 for them to be perpendicular. Why? Watch here. Here's perpendicular. Here's a line. Here's a line. If this one is positive, this one must be negative. If this one's gradient is 3/1, this one will be 1/3. So if you multiply the two, will always give you -1. Positive times negative is a negative. And the one fraction times its opposite times its reciprocal will always equal to -1. So 3/1 times 1/3 will always equal to how much? -1. Common sense. Right. It's also used for what we call collinear points. Collinear means you need to prove that 3 points are in a straight line. Where the points are in a straight line. So if we had 3 points, point A, point B, point C, we need to prove that the gradient between these 2 points is equal to the gradient between those 2 points. That is when gradient is used. So if you want to prove, if they ask you, is A, B, and C collinear? You'll have to calculate the gradient between A and B, calculate gradient between B and C. If the gradients are the same, they're on a straight line. Because on a straight line, the gradients are the same throughout. So very important, the distance formula, AB is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Remember that. Gradient formula, y2 minus y1 over x2 minus x1. These are just the formula. We're going to do an exam model just now. After this, I'm throwing you into the deep end. I'm going to put a model. We'll ask you every humanly possible type of, and hopefully, inshallah, you will get 100% and full marks for this in your exam. And it's something you're going to look forward to. It's not something you need to be afraid of. It's something you want to look forward to because it's a topic you can bank marks. This is where you can score marks. Onliners, are you with me? Right. Let's go. The next formula that you need to know. So the first 2 formulas, let's just circle it. This is what you're going to test yourself before your exam. Do you know these formulas? Distance formula, gradient formula. The next formula you need to know. The next formula that you need to know is the midpoint formula. The midpoint of a line. Now, the midpoint, we want to, it's given in a pair of coordinates. So x midpoint is equal to x1 plus x2 over 2. Learn this as an equation. I know sometimes at your schools, they don't put this x midpoint. They just say x1 plus x2 over 2. You learn it like that. Don't do it like that. I'll tell you why. Because sometimes the midpoint is given and you need to find. So let's just use one formula. X midpoint is equal to x1 plus x2 over 2 as an equation. I'll show you how important this is. And y midpoint is equal to y1 plus y2 over 2. Meaning, watch here. Let's do the two scenarios. Watch here. Right, example. So say I got a point here, point A, and I got point B. And I draw a line between the 2 points. I tell you A's coordinates is -6 and 4. I tell you B's coordinates is 12 and 20. Right. Find the midpoint M. Find the midpoint. Right. Pay attention. I'm doing two scenarios. This is scenario A. So let's call this type 1. Type 1. We are doing two types. Type 1 of 2. Right. So you're going to get two different scenarios. Yo, we get Vida Cafe here, bruh. Right. Find the midpoint. Watch here. Watch here. So let's do this. Let's all do it together. Onliners. Shukran. Cheers. Right. Let's go. So we need to find the coordinates of the midpoint. So in our answer, x midpoint, write it out. X midpoint is equal to, let's call that x1, y1. Let's call that x2, y2. Please pay attention. Substitute correctly. Right. x1 plus x2 over 2. x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. So x midpoint is equal to, that will give me 6 over 2, am I right? Which is 3. Y midpoint is equal to 24 over 2, which is 12. Therefore, the midpoint here is 3 and 12. Therefore, your midpoint is 3 and 12. So here we go, 3 and 12. Game over. You'll get yourself 3 to 4 marks. Easy. Now, what if so take this one down. Now I'm going to erase B's coordinates and I'm going to give you the 3 and 12. That's why I told you to write this formula as an equation. Please pay attention to this, guys. You need to pay attention. You need to pay attention. No sugar. I've got some sugar there.
I think I can sing you a song about Seika here.
Yeah.
No sugar policy.
This is Cape Town. Who knows a song about sugar here? Anybody knows? Seikar bosek valyo hai.
Now I'm gonna be imposing a sugar
Seikar bosek valyo hai.
Oh, soki. There we go. Your sugar.
Batsalyo mama dafanse. And in Malay, sakrita nevane ase.
Am I supposed to be dancing?
That's the Cape Coons.
Yeah.
Yeah, sakrita nevane
But
ase.
this is soki, this, man.
Huh?
Yeah.
Yeah. Right, let's go. Let's go. Right, now watch. You see the importance of this formula now. Watch here. I'm doing this to highlight the importance of the formula. Now I give you the midpoint. Watch here. Shh. Now this is very important. Right up to grade 10 to 12. This is very important. Because they'll ask you to prove something to be a parallelogram. I'll show you when we get to it. Now, they call this X and Y. If M is the midpoint of AB, find the coordinates of B. If M is the midpoint, find the coordinates of B. Now, we know what B is going to be. Obviously, whatever it was before, because we're using the same midpoint. So now, but you need to get to it. You need to get to it. Work it out. So now start with the formula. So let's go. X midpoint is equal to x1 plus x2 all over 2. Just now. Shukran. And y midpoint is equal to y1 plus y2 all over 2. So this is x midpoint. That's y midpoint. That's x2, y2. Right. Substitute in your formula and solve for x and y. Substitute into your formula and solve for x and y. So x midpoint 3 is equal to x1, which is minus 6, plus x2, which is x, all over 2. Y midpoint is 12, is equal to y1, which is 4, plus y2, which is y, all over 2. Now we need to solve for x and y. Fresh Cape Sisters for the take.
Getting the first class.
Yo, I'm getting spoiled here, bruh. Right, let's go. Let's go. We're solving for x and y. Times 2 times 2. 6 equals minus 6 plus x. So x is equal to 6 plus 6 is 12. 24 equals, we times this side by 2 times that side by 2. 4 plus y. So y is equal to 24 minus 4, which is 20. So this must be b's coordinates. B's coordinates is 12 and 20. And there we go. That's how we do it. 12 and 20. Right, here goes. Are we all okay? Onliners, take this template down. Very important template to take. Very, 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 very important template to take. Thank you, Damien. Glad you're appreciating the work. Let's go. What you say we do every weekend math? How quiet? You guys ready? You guys ready for weekend math? Weekend special. All right, let's go, let's go, let's go, let's go, let's go, let's go, let's go. Now that's pushing it. How about next year when you guys are in grade 11, we have this big group at ICC with all the learners, all the grade 11s from around Cape Town at ICC. CTICC. CTICC. Will you guys fly down from wherever you are for the Cape Town International Convention Center where we're doing cracking math over 2 days with 10,000 learners? How awesome. We'll make history, brah. We'll make history. It's fine. Much more, Leila. Much more to come. Right. So that was your midpoint formula. One more formula. One more formula. The equation of a straight line. The equation of a line. So this is, what's it? Formula number 4. The equation of a line. The equation of a line. We know y is equal to mx plus c. Or if we given one point and given a point and the gradient. So say you're given one pair of coordinates and you're given the m of the graph. So you're given a point and you're given the gradient. You can use this formula y minus y1 equals m into x minus x1. Have you guys seen this formula before? No. Now this is so easy. Because if you're given a point and given the gradient, you just substitute it into here and remove the brackets. It will end up as y is equal to mx plus c. So let's do an example of this. So say you're given the gradient. Say you're given the gradient as a half. And say you're given a point as 4 and 6. Let's say point R. Now they say find the equation of the line. You're given the gradient and you're given a point. Check this. Let's use this formula that I just gave you now. Y minus y1 equals m into x minus x1. Check it out. Watch here. Put your pens down. Put your pens down. See how nice is it? There's the half. We're going to put it there. We can call this one x1, y1. Watch here. Y minus 6 is equal to m, which is a half, into x minus 4. There we go. Now we just remove the brackets and we'll get it. Y is equal to mx plus c. So y minus 6 is equal to, let's multiply that out, a half x minus 4. 4 times a half is 2. Now take the 6 on the other side. Here's your final answer coming up. Y equals a half x minus 2 plus 6. Minus 2 plus 6 plus 4. Final answer, the equation of your line. Nice, ne? Just using one formula. So you don't need to do y is equal to mx plus c, put in the gradient, find c, take c, put it all the way back. You're doing it all in one formula. So learn this formula, y minus y1. Y minus y1 is equal to m into x minus x1. Right. Here we go. Right. Are you ready? Let's give you, we're going to do one exam model and then we're going to go into break. Yeah. Here we go. Here we go. Take this down, learn this formula. It's a nice formula to use. You'll use it till grade 12. In fact, you'll even use it in functions. You can even use it in a topic in grade 12 called calculus. So you'll use it from now till grade 12. Right, here we go. Relax. We're going for break now. We're going for break now. We just got one exam model to do. I've taught you your formulas and we're going for break. Hang in there. Hang in there. And after break, right, here goes. Here goes. Here goes. Right, you've taken this down, hopefully. You're all okay with this? Right. Let's see who's going to get 20 marks in the exam or full marks. So here's an exam model. Are you ready? Can I clear the frame? Who's still writing? Come, hurry up. No, we don't do physics. Just math. Just math. Right. I'm sure you guys done. Let's go. Right. This is going to take us to break. Shh. Right. Take this diagram down. Here we go. Here's an exam model. Quiet. Quiet, 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 quiet. Take this down. Take this down. This is point P, Q, R. That's 0. That's your y-axis. That's your x-axis. Shh. Right. This is 4 and 20. That there is minus 10 and 2. R is 16 and negative 8. Quiet, quiet. And we have a point here, S. X and Y. This point, P, Q, R, S. And that's X and Y. Right. Question number 1. And that is M, the midpoint. Question number 1. Find the midpoint of QR. That's easy. 3 marks. Right. Find the equation of PM. Find the equation of PM. Question number 3. I want an equation of a line parallel to PM, passing through R. Right? Wait, relax, relax, relax. Right. Now I want the coordinates of S. Okay, wait. Let's ask you another question. Is PM perpendicular to QR? Show all calculations. And I want the coordinates of S. Find the coordinates of S if PQRS is a parallelogram. Right, mark allocations, guys. Find the midpoint, 3 marks. The equation, 4 marks. The equation here, 5 marks. Is PM 4 marks. Find the coordinates of that, 4 marks. 4, 8, and 5, 13. 13 and 4, 17, and 3, 20. Yo, how quite on the dot, 20 marks. There we go. There's your 20-mark question for your exam. Let's start working on it, and this will take us straight into break. Inshallah, we should be done. We got 10 minutes. You want to try it on your own so long? Or must I do it with you? Guys, you don't even need break, man. You just need to have your refreshments and everything with you, and we just boost until the end. Why do we need? Huh? Yes, sleep is overrated. The day you die, you're going to sleep for a long time. Make the best of while your eyes are awake. Shame. You guys have been hit by the math bus, the math train. I know math is stressful, but to be successful, you have to be stressed. There's a direct relationship between stress and success. Sound like Tate? My man.
You sound like a psychologist there, Mr.
You know my
Mr.
man
Khota.
Tate. You know my man
Stress
Tate.
and success.
What did Tate say? He sang that song, "Baby, come back. You can blame it all on me. I was wrong." And they sent it all to all my girlfriends. And they said, "Did you mean it?" "No, I didn't mean it." It was hilarious. Stress is success, Mr. Robbie. There we go. Let's go. Let's go. A math train, math shark, math human, math house. Top K. Leave Tate. Tell Tate I'm coming for him. I'm right behind him. What color is your Bugatti? Yeah, let's go, let's go, let's go. You can't succeed. You can't succeed if there's no stress. You need to have a high level of stress tolerance. Anytime, anytime, set it up. Tell him I'm waiting. Let's go, let's go, let's go. Let's go. Who's driving a tuk-tuk? That's the name. They got jokes, these people. Nah? They got jokes. They got jokes.
What they saying there, Mr. Khota?
They say I can't be Tate. I'm driving a tuk-tuk.
Yellow card, yellow card.
No, it's fine. It's fine. Wait till they see me flying past the waterfront, bruh. Then they know what we in.
Yes.
Let's go, let's go, let's go. No MK2s here, bruh. Right, let's go, let's go, let's go, let's go. Right, let's do it here on the side. Right, let's go. Let's do the calculations here, guys. The midpoint of QR. So the midpoint of QR, x midpoint is equal to x1 plus x2 over 2. I'm answering question number 1. Y midpoint is equal to y1 plus y2 all over 2. Shh. So we want the midpoint of QR, which is M. X midpoint is equal to x1. Let's call that x1, y1. Let's call that x2, y2. x1 plus x2 over 2. Y midpoint, that's x and y. Y midpoint is equal to y1 plus y2 over 2. And that will give me 6 over 2, which is 3. Whoa, so it's actually on that side. And 2 minus 8 is minus 6 over 2 is minus 3. So it's actually 3 and minus 3. Actually, the M, the midpoint is not here. M, the midpoint is actually on the other side. Quiet, quiet, quiet. M, the midpoint is somewhere there. M, the midpoint is 3 on my x and minus 3 on my y by calculation. That's the accurate position of M. Right. Did you all get that right? Onliners, you got that right? 3 and negative 3. Excellent. You can't bring an electric car to South Africa. No power. No electricity. Trust me, after elections is load shedding stage 64. Right, let's go, let's go. This is Africa, Baba. This is Africa. Bicycles and horses for us in 10 years. We're counting on you. We're banking on you, grade 10s, to come up with a new formula. Give us lights. You are our last hope. Right, let's go, let's go, let's go. Number 2, the equation of PM. Now listen. Let's do this together. The equation of PM. The equation of PM. I'm answering question number 2. Firstly, we need the gradient. Listen. We're answering this one here. The equation of PM. So I need the gradient. The M, the gradient is y2. Y2. So let's call that x2, y2. Let's call that x1, y1. Y2 minus y1, minus 3, plus 3. Do not forget to change the sign because of the minus from your original formula. It's y2 minus y1. So minus 3. Negative times negative is a positive. Over x2 minus x1, we get 23 over 1, which is 23. Right. The gradient is 23. Now we want the equation of the line. So now we can use that shortcut formula I showed you. Y minus y1 equals m into x minus x1. I got the gradient. I got a point. I'm going to use 4 and 20. So y minus 20 is equal to 23 into x minus 4. Y minus 20 is equal to 23x minus 23 times 4. 23 times 2 is what? 46, 92. So y is equal to 23x minus 92 plus 20 is minus 72. And there we go. That is your answer. Y equals 23x minus 72. Hope you all got that one right. I know the Prince 56, I know they are electric cars. But obviously the guy's got to have solar batteries at home to charge his car. This is Africa, man. How much time do we have? Whoa, we got a minute left. We got a minute left. All right, let's continue immediately. Let's go for break. Let's come back. Let's do the memo for this, and then we start with trigonometry. Enjoy the break. Enjoy the break. Enjoy the break. I see you guys at 11 o'clock.
2 1 1 1 1 1 2 1 1 2 1 1 2 1 1 2 1 2 testing 1 2 1 2. Is that fine, Hassanan? 1 2 1 2 testing 1 1 2 1 2 1 2 1 2 1 2 1 1 2
Welcome back, learners. Welcome back. Settle down, please. So we're about to get the show on the road, but we've got a special announcement. I think Mr. Baker has got a special message or announcement. So I'm going to hand over the mic to Mr. Baker.
Okay, thank you, students. You know, students, maths, as we all know, is a very important subject. And as I mentioned earlier, maths opens doors. Maths teaches you problem-solving skills. Those of you one day, you know, when you matriculate and you've got maths on your certificate, I can tell you now, if that employer has to choose between yourself and somebody else who's got mathematical literacy, they are definitely going to choose you. And I just want to say this also, students, many of you are still unsure about the career paths that you wish to follow. I want to say this, students, please think about your career path, because if you are thinking about it, if you are making certain decisions about it, you will obviously also know how important your maths is and what the requirements are for that product. For example, physiotherapy. Some of you are interested in physiotherapy. Whether it is at UCT or at UWC, I say minimum 60% in pure maths. But I don't also know what it's going to be like in 2 years' time. Then also students, amongst us here, there are 1 or 2 students who are celebrating a birthday. And so I just want to wish Aman Abrams a happy birthday. She's here today. She should have been at home opening presents and enjoying the morning with a family, but she's here for maths. And so happy birthday, Mubarak to Aman Abrams on her birthday. And let us sing happy birthday to her. So you, at the count of 3, happy birthday to you. Happy birthday to you. Happy birthday to Aman. Happy birthday to you. Hip hip hip. Hip hip hip. Hip hip hip. Thank you.
Thank you. Over to you, Mr. Khota. Let's get the show on the road. Happy birthday. Have a blessed day.
Okay, we are back. Let's get that whiteboard up. Hope you guys had an energizing comfort break. Talking about a birthday that Iman is now, or Aman. Iman or Aman? Aman. She's here on her birthday. I am missing out on a very, very important family function as well in Johannesburg. We got a wedding in the family, and I am here sitting and tutoring math. Well, it's all for a better cause. Right, there'll be many more functions hopefully to come, and I'm with them there in heart and spirit.
Sterkte, Mr. Khota. It's very hard for Mr. Khota. All of his family have joined in from across South Africa. They're in Johannesburg for a very important family wedding. Mr. Khota cannot be with his family. He's very dedicated to the cause. So, Mr. Khota,
Amen.
sterkte to you, and we
Amen,
appreciate
amen,
your
amen.
dedication. Over to you.
Let's go, let's go, let's go. We're live and kicking. Here goes the whiteboard. Okay, guys, I hope you guys had a lekker break. We're back here. I know some of you have been working through the break. I've seen that. I've seen some of you onliners cracking all of them through the break. Let's remove that. We're now going to find the equation of a line. We're going to finish this up. I want to do changing the subject of the formula after this, because that's also an important topic. And then we are going straight into trigonometry. So guys, we are back. Let's do number 3. The equation of a line parallel to PM passing through R. So parallel to PM. There's PM, guys. Here we go. There we go. There's PM passing through R. So here goes. Somewhere there. We're just drawing a rough sketch. Parallel. So you know parallel we indicate by 2 arrows. Okay. Now we've got, in the previous one, we found the gradient of this line because we found the equation. What was the gradient? Somebody give me the gradient. Was it 23? Right. So the gradient of PM, the M of PM is equal to 23. So the M of your new line is also equal to 23. The M of your new line is also equal to 23. Why? Why? Because the two gradients are equal. Yes or no? Guys, are you following? Right, here goes. So now y minus y1 equals m into x minus x1. We can choose, now it's going through R. It's going through R. And what's R's coordinates? 16 and minus 8. Are you guys following? I'm putting a tick there. Are you following what's happening? Okay, here goes. Don't worry about the comments that are coming about. Worry about the numbers on the side. That's going to get you your distinction. Right. So here goes. Y minus minus 8. Y plus 8 is equal to 23 into x minus 16. So y plus 8 is equal to 23x minus, now we go to our calculators, 23 times 16, 368. And your final answer, y equals 23x minus 368 minus 8 is minus 376. And there we go. You've got yourself your next 5 marks. So 3 and 4 is 7 and 5 is 12. You got 12 out of 20. You've got 60% for this question already. Thank you, guys. Thank you, Shadley. Thank you, Yahya, Kwezi. There we go. Have a blessed day, babes. It's coming. It's from a girl. Yeah. Right. Right, let's go take this down. Right, now we're going to do number 4. I hope you've taken this one down. Please take it down. Take it down. Take it down. We're doing number 4. Is PM perpendicular? So we need to find out what is the M of this line. And we need to find out what is the M of that line. We need to multiply it and see if it's equal to -1. Yes or no? For question number 4, please follow. Please follow. Math requires concentration. Focus. Thank you. I'm erasing the previous one. I'm erasing the previous one. And I see our onliners are doing very well. They're working lovely. They're fully activated. Well, let's say most of them. Here goes. Number 4 is PM perpendicular. So let's work out. So we know the M of PM is equal to 23. Is it perpendicular or 90 degrees to QR? So the M of QR is equal to the M of QR. Y2 minus Y1. Be careful here. Minus 8 minus 2 over 16 minus x2 minus x1 minus 10 plus 10. So that gives me negative 10 over 26, which is equal to minus 2 goes into there 5 times, 2 goes into there 13 times. Now, 23, the M of PM, 23, multiplied by minus 5 over 13 is not equal to minus 1. Therefore, PM is not perpendicular to QR. You must show the calculation. They want you to prove. That's why they say show all calculations. That's why they say show all calculations. In mathematics, you just got to justify your steps. As long as you're justifying your steps mathematically, you are good. How's our onliners doing there? All right. Yes, it's false. It's not. Thank you, Mango Fish. Right. The last one. Quiet. Hope you've taken this one down. This is a big session. This is a big session till our lunch break. We're going to be finishing up this analytics. I just want to do changing the subject of the formula. Very important because you're going to use it in every topic. Even in finance this year. Even in number patterns this year. In every topic, you're changing the subject of the formula. Right. Let's do number 5. Let's do number 5, guys. And thank you all for being so diligent. Thank you all for being so committed and being activated into the program. We're going to see you many times this year, inshallah. Can I get an amen? Ameen. All right, here goes. Find the coordinates of S if PQRS is a parallelogram. Right, now forget about this line. This line's got nothing to do now with the next question. Right, they're telling you that PQRS is a parallelogram. PQRS. From there to there, from there to there. It's a parallelogram. Pay attention. Now, how do we prove? They're telling you it's a parallelogram. How do I get? So we know that that side is parallel to that side, and we know that that side is parallel to that side. How do we find the coordinates of S? I'll show you the best way whenever you're dealing with parallelograms. Use the midpoint. Midpoint is the easiest way because you know in a parallelogram, your diagonals bisect each other at a common midpoint. Right. Let's use the midpoint. I'm answering question number 5. I'm answering question number 5. Let's go. So we need the midpoint of PR will be the same as the midpoint of QS. They share a common midpoint. They share a common midpoint. Don't use distance formula. Don't use gradient formula. Don't use, yes, you could use it, but it will take you a long way to do it, and it will take you over a page of calculation. It's not where you want to be. So just use the midpoint formula. So the midpoint of PR, is x1 plus x2 over 2, 4 plus 16 over 2, and 20 minus 8 over 2. 4 plus 16, 20 over 2 is 10. 20 minus 8 is 12, over 2 is 6. So the midpoint here is 10 and 6. Now we can find S. To find S's coordinates, now we got to use the equation. X midpoint is equal to x1 plus x2 over 2. Y midpoint is equal to y1 plus y2 over 2. Can you see how important this formula is that I showed you in the beginning? Right. So x midpoint we got 10 is equal to x1 minus 10 plus x2, which is x, over 2. Y midpoint is 6 is equal to y1, which is 2, plus y2, which is y, over 2. Let's solve for x and y. 20 plus 10, x is equal to 30, times 2 times 2, 12. 12 minus 2 is 10. Y is equal to 10. So S's coordinates is 30 and 10. And there we go. You got yourself 4 marks for that. The midpoint of PR is the same as the midpoint of QS. And we can find S's coordinates if PQRS is a parallelogram. Because one of the properties of a parallelogram is that the diagonals bisect each other. And they cut at a common midpoint. So the minute they use the word midpoint, we know we got to use midpoint formula. All right. Lovely. Done. 20 marks, guys. 20 marks for analytics. Analytics will only deal with distance, gradient, midpoint, equation of a line. That's it. That's it. There's nothing else that is used just besides those 4 concepts. Distance, gradient, midpoint, equation of a straight line. And you'll get full marks for this topic. Okay, let's now go into equation of a, changing the subject of the formula. We call it literal equations. Quickly, just to show you how it's done. Right, so put the heading literal equations. Literal equations, watch here. Literal equations. That's the proper mathematical term. We are changing the subject of the formula. You're going to get one like this in your exam. Changing the subject of the formula. Now, it's very easy. We use the rules of equations. The rules of this game is to use the rules of equations. Only thing, you don't have values. You got unknowns. So watch here. Watch here. Watch here. Watch here. So if they tell you A minus BX is equal to C, solve for X. Or make X the subject of the formula. Question, answer. I know this is easy, but we're going to pick it up from easy to difficult. I'm going to give you, but they're not difficult. It's lovely and it's free marks. It's marks for Mahala. Okay, let's go. Shh. Put down your pens. We need to get to X. So do me a favor in your exam, in pencil or in a different color, just circle that because we're looking for X. Right, now watch here. Shh. Minus BX, because that's attached. That's stuck, so it stays. Remember, it's a simple law of physics. What's stuck stays, what's loose moves. Loose means positive or negative. Stuck is multiplication or division. So what's stuck stays. Multiplication and division is like super glue. Sticks to a number. Positive, plus a number, minus a number, it's loose. So what's loose moves. So watch here. C is there. Plus A will come on the other side as minus A. Now pay attention. It's stuck. So we do the opposite because we need to get to X. It's multiplication. What's the opposite of multiplication? Remember, what rules are we using for this game? Correct. So what do? We say divide by minus B, divide by minus B, minus B cancels. Here's your answer. X is equal to C minus A over minus B. You can leave it like this, or you know, more mathematically correct, we never leave a negative at the bottom. So if we're dividing by a negative, both these signs change. So minus a will become plus a, plus c will become minus c, and over b. So whether you left it like that or like that, you'll get it right. This one here on this side is just more mathematically correct. But don't stress, you'll get the marks either way, there or there. Okay? Well done, Hassanin.
Well done to you, Mr. Khota. You're on a roll today.
Yeah, always, brah.
You slept well last night, eh?
Yeah. All right, let's go. We don't sleep. At Kway, this is part of the no sleep club. Eat, sleep, and drink math. C minus A over B, no. C minus A over B, no. It must be A minus C over B or C minus A over minus B. That's in response to who? Was that mango fish? No, Suraya. C minus A over B. Lahiri. C minus A over B, no. It's C minus A over minus B or A minus C over plus B. You cannot have C minus A over B. What happened to the negative? Where's your negative? That's incorrect. Hope that answers your question, Suraya. Right, let's go. Let's go. I'm clearing the frame. I'm clearing the frame. Okay. Let's start with this one. Let's pick up the pace. Let's pick up the pace. S is equal to 2 pi r into h plus c. Make c the subject of the formula. Question, answer. We're going to do 2 more after this. We're going to do 2 more and the topic is done. We're just using our rules of equations. That's it. Right. So watch here. I need to get to C. So I'm just going to flip the 2 sides around. 2 pi r into h plus c is equal to s. That's a s, not a 5. We divide this side by 2 pi r because it's 2 times pi times r. What I do on the left, I do on the right. That and that will go. What am I left with? H plus c equals s over 2 pi r. I need to get to c. So take the plus h on the other side. Here's your final answer coming up. S over 2 pi r minus h, sorry. Minus h. Because we're taking h over on the other side. And that's it. That's it. You've made C the subject of the formula. Now, if they gave you the radius and they gave you the height, you just plug it into here and you can find the value of C as well as S. Right, here we go. Right. Quiet, 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 quiet. Here we go. Right. You've taken it down. For those of you who are done with this one, try the next one. I won't erase the whole thing. Here we go. Next one. F is equal to mv squared over gr. Make r the subject of the formula. Quiet. Number 1, make r the subject of the formula. Number 2, make v the subject of the formula. So I want you to do same formula, I just want you, the first one, I want you to make R the subject of the formula. And the second one, I want you to make V the subject. They're two different problems. That one's worth 3 marks. That one's worth 3 marks. Total marks 6. Shh. They're two totally different problems. I'm erasing the previous one. Right. In your answer for question number 1, you can make that over 1. We want R, so let's circle R. We want R on the top. So in an equation, you can flip this side, you can flip that side. So watch here. GR over mv squared is equal to 1 over f. Right? We flip it over, flip it over. What you do on the right, you do on the left. We want to get to R. So times this side by mv squared times that side by mv squared. So GR is equal to so that's over 1 mv squared over f. Right? We multiply this side by mv squared. What I do to the left, I do to the right. So mv squared is gone. Right. Now I need to get rid of g. So you can divide by g or times 1 over g. So you can multiply that side by 1 over g. That and that will cancel out. R is equal to mv squared over gf or fg. Gf or fg, it's the same thing. That's your final answer. Yes. Well done, Mango Fish. Now make V. Do the next one. Do number 2. Make V the subject of your formula. Make V the subject of your formula. Let's go. You all took this one down. You all understand this? Shh, girls. You understand this? Are we okay? You understanding what to do here? Good. Do number 2. Make V the subject. Use your rules of equations and make V the subject of your formula. Same equation. F is equal to mv squared over gr. F is equal to mv squared over gr. Make V the subject of your formula. Let's go. V equals square root of F. Yeah, Mango Fish. All right. Okay, so V is on the top. So in my next step, I'm going to say mv squared over gr is equal to f over 1. I just swapped the 2 over. A equals B or B equals A is the same thing. Shh. Multiply this side by gr. Multiply that side by gr. Gr and gr will cancel. mv squared is equal to f times gr is grf or fgr. Listen, quiet. We need to get to V. Divide by M. Divide by M. M and M cancels out. V squared is equal to FGR over M. This is squared. I don't want V squared. I want V. What's the opposite of square? Square root. So I find the square root on this side. I find the square root on that side. Your final answer, V equals the square root of FGR over small m. And there we go. I hope you all got that one right. Okay, let's give you one last one. AX minus 2x is equal to m. Make x the subject of the formula. Here's the last one I want you to do. That's the last one I want you to do. Square root of MGR. No, it's not MGR over M. It's FGR over M. Right, this is the last one I want you to do. This one in the corner. And then we go into trigonometry. Now, I know many of you haven't done it, but we're going to start trigs from the start, and hopefully by the time you guys get to it in school, you'll know, you'll be a master at it. Right, here goes. Let's finish this last one, guys. Quiet. So we got ax minus 2x is equal to m. All I do, solve for x. I got two terms. I take out x. I'm left with a minus 2, highest common factor, is equal to m. I divide this side by a minus 2. I divide that side by a minus 2. Here's my final answer. X is equal to m over a minus 2. I factorized by using the HCF. I hope you all got that one. Yes, x equals m over a minus 2. Yes, yes, Laiba. Very good. Very good. Laiba's mango fish got it right. Nabila. Right, let's go. Havish, good. Shh. Learn these examples, guys. Learn these models. Now you need to pay attention. Those of you who haven't done trigonometry, let me explain to you what is the purpose of trigonometry. Now, from the purpose, you'll understand where it's used and you'll begin to love trigonometry. Shh. It's a big topic in 10, 11, and 12. Huge topic in paper 2. Now, if you haven't done it, you will do it. You'll probably write it in June. And you're going to write it in September. Every time you write paper 2, you will write on analytics, you'll write on trigonometry as a topic, data handling, and Euclidean. Yes. Right. Pay attention, guys. Right. Thank you. Grade 10s. I need your guys' full attention because I know you guys haven't done it. Yes or no? Here at SP, you haven't done it. So, right. So, pay attention. So you need to pay attention, otherwise you're going to be completely lost. Okay. For grade 10s, listen to me. You only deal with 90-degree triangles. Pay attention. The word is trigonometry. The study of triangles. The study, and which type of triangle for grade 10? The 90-degree triangle. Now you might say, but I know everything about a 90-degree. I know Pythagoras, listen. I know Pythagoras and I know that the sum of angles add up to 180. But, hear me out. If I gave you a 90-degree triangle and I call this angle Q, and I told you this is 5, and I told you this is 10, and I said find angle Q. Right. With the knowledge that you currently have, the only thing you can do, grade 10s, again, I'm saying, assuming you have never seen trigonometry before in your life. With the knowledge that you currently have, the only thing you can do, if this was triangle PQR, is to find RQ, the side. You will use Pythagoras. However, I want you to find angle Q. Now you got two unknowns. Now you are stuck. Listen, put down your pens, do not write. Because I need to put you into the picture as to why we use it. Now this is the beauty of trigonometry. Trigonometry helps you to find angles by being given sides or sides by being given angles. So hear me out. I'm going to write it. Trigonometry helps you to find sides from angles or angles from sides. Now in this case, we need to find an angle. So we need to find an angle from being given sides. So that's the purpose of it. This is the purpose of it. Now, in order to do that, we use 3 Greek terms: sine, cosine, and tangent. In fact, for grade 10, you use 6. But don't worry about the other 3. I'll show you the other 3 later on. Right, pay attention. Pay attention. We need angle Q. We need angle Q. Now, that symbol is angle theta. This symbol is angle beta. And that symbol, like a fish or an X like that, is called angle alpha. Now pay attention. It's the same as in algebra A, B, and C. It's called theta, beta, alpha. It's like X, Y, and Z, your unknowns in algebra. So let's call that angle theta. So they want you to find angle Q, or they could say in the exam, find angle theta. Theta just refers to an unknown angle. Now hear me out. Hear me out. The first thing that you do, you use Pythagoras to finish it, right? Let's use Pythagoras to find RQ. Let's use Pythag to get RQ. So I'm going to erase that. Pay attention. Pay attention. Let's use Pythagoras to finish the sides. So 10 squared. The square on our hypotenuse, that's your hypotenuse, is equal to RQ squared plus PR squared. So 100 is equal to RQ squared plus, what is PR squared? 5 squared. It's 25. So RQ squared is equal to 100 minus 25, which is 75. So RQ is equal to the square root of 75. So there we go. And the square root of 75, if you simplify it, the square root of 75 is 5 root 3. That's in its simplest form. We don't use decimals. Let's put it here, 5 root 3. Okay, so we use Pythagoras to find the 3 sides. Now we need to find the angle. What did the question say? Find angle Q. Put down your pens. Watch what we do. Otherwise, you're going to be lost. That's the angle we're looking for. The side, I want you to do the step number 1. Identify your sides. So this, the side opposite your 90 degrees, we all know is our hypotenuse. The side opposite the angle that they're looking for is called the opposite. The last side is called the adjacent. Pay attention. So the side label, so step number 1, label the sides. Right? Hypotenuse, opposite, adjacent. Step number 2, you use what we call SOHCAHTOA. Now, let me explain to you what this means. Sine, cos, and tan. This will help you to remember the ratios. What is sine? What is cos? What is tan? So pay attention. Sine is opposite over hypotenuse. Sine of angle theta, sine of your angle, is equal to opposite over hypotenuse. It's a rule. That's sine. Don't say sin, it's sine. Right? This is just an abbreviation. Cosine, cos of theta is equal to your adjacent side over your hypotenuse. And tan of theta is equal to your opposite over your adjacent. So these are your rules. So if you remember SOHCAHTOA, you'll be able to remember sine, cos, and tan. Now look, We want to find angle theta. So I can't use sine. Oh, I could use sine. Sine of theta is 5/10, opposite, because we got all three sides. We could say sine of theta is equal to opposite of, according to SOHCAHTOA, is opposite over hypotenuse. So sine of theta is equal to 5/10. Sine of theta is equal to, what is 5/10? A half. Yes or no? Now, whenever we look for an angle, we use the shift key. Whenever we look for an angle, when you are looking for an angle, you use the shift key on your calculator. So now go to your calculator, say shift, make sure your calculators are on degrees on the top. Say shift, sine, S-A-N, you can see sine, cos, and tan, shift, sine, and a half. Put a fraction 1/2 or 0,5. What do you get? 30 degrees. And there we go. We've now found an angle by being given sides. Wow. Like a vow. Right. There we go. So just remember, label your sides and then use SOHCAHTOA to finish. So take this down. Take this down. We're going to do more examples till you get used to it. And then we're going to start picking up the pace. Well done, Laiba. Well done, Dayan. Yes. Well done, Fasia, Mohammed Khan. Very good. Guys, trigonometry, what's the thing you do? Make sure you find your sides if you can. If two sides are given, complete it using Pythagoras and then label your sides O, A, and H. Then you use SOHCAHTOA. Sine, cos, and tan. Mango is clever. Maybe Mango is a teacher. Mango Fish, are you a teacher or a student? Now we know we've got some pictures from schools where we got one login. But there are probably about 100 learners or 50 learners behind watching the big screen at those schools. So although sometimes it might say 70 logins, but it's not 70. Now, one school may have 100, one school. So we probably got over 1,000 people that are watching today. Over 1,000 to 2,000 people that are watching today. Mango is AI. You could use sine, cos, or tan. Neo asks, how do you know which one to use? Okay, watch. So let's use cos and let's see whether we get the same answer. Watch here. Watch here, watch here, watch here. So we used sine. So somebody asked, Neo, I think Neo asked, Neo is the matrix. I think he's the blue pill or the red pill. Those of you who haven't watched The Matrix, I don't think you'll understand what we're talking about. Right. What if we tried cos? Cos of theta. Cos of theta is equal to adjacent over hypotenuse, depending on what you have in a diagram. In this one, we got all three, so no problem. I could have used sine, cos, or tan. Is adjacent over hypotenuse. So cos theta is equal to, what's your adjacent? 5√3/10. So theta is equal to, go to your calculator. Shift cos 5√3/10. Shift cos 5√3/10. Boom. 30 degrees. Wow. I get the same answer. Why? Whether I use sine, cos, or tan, theta is one angle. It must give us an answer in this case of 30 degrees. And even if I use tan, tan theta is equal to opposite over adjacent. So tan theta is equal to your opposite, which is 5 over 5√3. Check your answer. Theta is equal to 30 degrees again. In this case, in all triangles, whether you use sine, cos, or tan, will give you the same answer because it's the same angle you are looking for in that triangle. Are you all with me so far? Label your sides and use SOHCAHTOA. Label your sides and use SOHCAHTOA. It's as simple as that. Right. To test whether you are understanding this concept, right. Here goes. Yes. Philistus Ziwanai. Ziwani. No, I hope I'm saying it right. Philistus. Yes, Philistus. If you are looking for an angle, you use the shift key. You always use the shift key if you're looking for an angle. Right. If they just told you find sine of 30, say they gave you this as 30, I'm clearing the frame. Okay, let's do this. Let's give you the same triangle. Watch here. Pay attention. Say they gave you that as 30. Now they gave you that angle. They told you that is 5. What was the other side? This was 10. And that was 5 root 3. Now, if they told you to find sine 30, cos 30, tan 30. Now they gave you the angle. Sine 30 is 5 over 10. In this case, using the triangle, is 5 over 10, which is equal to a half. Cos 30, remember that's opposite over hypotenuse. Cos 30 is adjacent over hypotenuse. So that, remember, label your side. That's your angle, that's your opposite, that's your hypotenuse, that's your adjacent. Adjacent over hypotenuse, so it's 5 root 3 over 10. Now you can simplify this. 5 goes into 5 once, 5 goes into 10 2 times, root 3 over 2. Tan 30, tan of 30 is opposite over adjacent. 5 over 5 root 3, which is equal to 5 goes into 5 once, 5 and 5 will cancel. Your answer is 1 over square root 3. Now you don't use your shift key using this diagram. If they didn't give you a triangle and they just told you sine 42 degrees. Thank you, sir. Sine 42. You can just go straight into your calculator. In your calculator, punch in your sine key, punch in 42. That's it. No shift because your angle is given. Angle given. So no shift key. So now go to your calculator, say sine 42, boom, 0.669, which is approximately 0.67. That's your answer. Why didn't we use the shift key? Because the angle is given. When do we use the shift key? When we're looking for an angle. Yes or no? Are you understanding? So far, so good. Right. Let's go. Yes, Dayan. 0.669. Okay. Right. I'm now going to give you 3 models. Let's see if you can identify opposite, hypotenuse, adjacent, and you can answer the questions based on that. Let's start off with the first one. So take this one down. Remember SOHCAHTOA. The whole year, for the whole of trigonometry, SOHCAHTOA is your formula. No SOHCAHTOA, no trigonometry. You can't do trigs without SOHCAHTOA. Right? Oh, hell, another hour of algebra. SOHCAHTOA. Right, so to help you to remember, SOHCAHTOA, oh, hell, another hour of algebra. And then you just put sine, cos, and tan, SCT. Right. So there we go, there we go, there we go, there we go, here we go. Easy peasy, let's go. It's gonna get a bit rough. This is just the start. This is just the start. This is your ABCs of trigs. Shh. Quiet, quiet. If you pay attention now, it's gonna be a breeze at school. Right, I'm erasing. Right, here goes. I give you a triangle in this direction here. That's 90 degrees. I call that A, B, C. I call this angle theta here. Angle B is angle theta. I tell you that this is 2 centimeters. I tell you this is 12 centimeters. Question number 1. Find AB. Question number 2. Find sine theta. Question number 3. Find tan theta. Question number 4. Find theta. Now, if they ask you for sine theta, you just find sine theta according to SOHCAHTOA. Right, mark allocations. Find AB, 3 marks. Find sine theta, 3 marks. Tan theta, 3 marks. 3. Right. Pythagoras to complete. Identify opposite, hypotenuse, and adjacent. Use SOHCAHTOA to answer these 4 questions. Okay. We're going to take you from easy to difficult. Don't stress. Don't stress. Guys, it's 5 to 12 already. I told you people, before you know it, it's lunchtime, and before you know it, the day's over. Time to love you and leave you, and leave the province. Right, let's go, let's go, let's go. You should be done. Pay attention. We're answering question number 1. So, BC squared, we're using Pythagoras. BC squared is equal to AB squared plus AC squared. So, BC squared is 12 squared is equal to AB. They want us to find that. This is Pythagoras. AC squared is 2 squared. 144 is equal to AB squared plus 4. AB squared. 144 minus 4 is 140. Therefore, AB, here's your answer, is equal to the square root of 140, which is equal to, let's see, can we simplify that any further? Square root of 140, 2 root 35. 2 root 35. 2 square root 35. No need to convert it to decimals. Just leave it in its simplest third form. There we go. Easy peasy, Pythag. Question number 2. Find sine theta. So we're talking about theta. It's called our reference angle because we're referring to it. Right. So the side opposite, that's opposite. The opposite, your reference angle is opposite. Opposite your 90 degrees is your hypotenuse. And your remaining side is your adjacent. Right. They want sine theta. Watch here. Sine theta is equal to, from SOHCAHTOA, opposite over hypotenuse. What's your opposite? 2. What's your hypotenuse? 12. Simplify that. 1 over 6. That's where you leave it. Don't touch it. They didn't ask you to find theta. In this question, they said find sine theta. So we just leave it as opposite over hypotenuse. Are we all okay with that? Good. Number 3, tan theta is equal to opposite over adjacent. And guys, you can answer it exactly like this in your exam. Opposite over adjacent. 2 over 2 root 35. 2 goes into 2 ones. 2 and 2 will cancel. You're left with 1 over root 35. No need to rationalize your answer or denominator that you're only doing grade 11. Leave it like that. Right. Right. Now we want to find angle theta. So you can use sine, cos, or tan. I'm just going to use sine. I'm going to use sine. Sine theta equals 1 over 6. So therefore, theta is equal to. Right. We're looking for an angle. So what must I use? The shift key. Shift sine 1 over 6. Boom. 9,59 or 9,6 degrees. 9,59 or approximately 9,6 degrees. And there we go. We are done. We got ourselves 12 marks. Please learn this. Please learn this. 9,6. Mohammed Khan, 9. Do we shift this one? Yes, you shift it. Why do you shift it? You're looking for an angle. Got it all right. Well done, Tina. Well done, Dayan. Well done, Mohammed Khan. Good. Well done, well done, well done, well done, well done, Fasia. Right, let's go. Right. All right. Now, fantastic. Right. Pay attention here. You all got these right. Lovely. Everybody's getting them right. I hope you all took it down. I'm erasing. I'm clearing. I'm giving you some exam questions. Not on the triangle now. Some basic ones. Right. I'm clearing the frame. Right. Calculators are allowed. Shh. Calculators are allowed. Right. Fine. Question number 1. Cos 38. Question number 2. Cos squared 38. Question number 3. Cos squared 38 minus sine squared 38. You can use your calculators for this. 2 sine 29 plus 4 tan 40. Right. And here on this side, solve for theta. Watch here, watch here, watch here. Solve for theta. Give me a second. Let's pull some out here from your papers or from your book. Right. Question number 1 sine theta is equal to 2 over 5. 2 sine theta is equal to 0,6. Pay attention. Right. Cos 2 theta is equal to 0,7. Number 4, 4 over 3 tan theta is equal to 3. Number 5, cos x plus 30 is equal to 0,5. Number 6, 2 tan x minus 45 degrees is equal to 1. And the last one, 3 sine 3x plus 30 is equal to 3. Right. Shh. Mark allocations for all of these. I'm just giving you a whole lot of these. These are type of questions you'll be asked under trigs without a diagram. So this you just got to use your calculator. 2 marks for that. Quiet. 2 marks for that. 3 marks for that. 4 marks there. 2 marks. 2 marks. 3 marks. 3 marks. 4 marks. 4 marks, 4 marks. In red is your mark allocations. Don't do it, I'll do it all with you. Those of you who have done it in school, start with it. You have to, this is all calculator work now. They want to test whether you know how to use your calculator for these. Here, no shift. Why? Because angles are given. Here, you got to use your shift key, because you're looking for an angle. Right, wait, relax. Those of you who haven't done it, it's fine. I'm going to go through it step by step. Learn these. After this, we're going to do what we call reciprocal, opposite functions. What's the opposite of sine? What's the opposite of cos or cosine? And what's the opposite of tan? Tangent. These are just Greek words. And what do they represent? Sokatoa. Sine represents your opposite side over your hypotenuse. Cos represents your adjacent over hypotenuse. Tan represents your opposite over adjacent. Okay? I know it's a lot. I know it's a lot to absorb, but it will all come to you when you're going through the notes and when you're re-watching the Awqaf program on the site. Let's see how's our onliners doing. Onliners, there we go, there we go, there we go. These are all from past papers. These are all exam questions. Okay. Now, I'm just going to remove the mark allocation so we don't get confused. Okay. Right. In fact, let's do this. Let's do this. Let's put a line there across. Let's answer these ones here at the bottom in red. Right. So here's your answers at the bottom. Question number 1, cos 38. Very easy. Straight into your calculator, punch cos 38. Make sure your calculator is on degrees on the top. It must have a D. So cos 38, close brackets, equals 0,7. If they say correct to 2 decimal places, They want all of them correct to 2 decimal places. So your answer here is 0,788. Correct to 2 decimal places. You look at the third one after the comma, 0,79. Did you all get that one right? Straightforward into your calculator. Easy peasy, lemon squeezy. That's the first one. So the first one's done. The first one is done. Easy. Let's do question number 2. Cos squared 38. Be careful. Right. Basically, listen to me. Quiet. Cos squared 38. You can't square cos. You're squaring the angle. Basically, this is written like this. Cos 38 squared. It's the same. Shh. Pay attention. Now work it out on your calculator. Say cos 38. Cos 38 equals. And then press the x squared button on your calculator. Answer squared. 0,6209. Correct to 2 decimal places. We look at the third one. Your answer is 0,62. Learn. Please, guys, you need to learn this from grade 10 to 12. 100% you're getting tested on this. You're getting tested on the diagram, how to use Sokotoa. You're getting tested on how to punch into your calculator. You're getting tested on how to solve for angles. Then you got reciprocal functions and how to solve more complex diagrams. We're getting to that. We've covered a lot, guys. Hopefully by today, we would have finished the whole year's trigonometry. So by the time your teacher gets to it, you solid. Swallowed. Swallowed. What the jweed? Swallowed. Right. Number 3. Here we go. Cos squared 38 minus sine squared 38. Now, plug this into. So basically, you're going to do on your calculator cos 38 squared minus. Now you're going to put brackets. You're going to say sine 38 squared. Now wait, let's go. So let's say cos 38 close bracket squared minus sine 38 close bracket squared. Boom. 0,2419. Correct to 2 decimal places, 0,24. I hope you all got that one right. Let's check our 0,24. Yes. Well done, well done, well done, well done. How are you leaving us, brah? Mango fish. Salute. You have left the building. Why are you leaving? Thank you, Mr. Top K. Hey, thank you, Mango Fish. Don't leave us, brah.
Gone to Dubai. Habibi, come to
Habibi,
Dubai.
gone to Dubai. Gone to Dubai. Habibi took the next flight out of the house. Upstairs, downstairs, DVD. He's gone. Bye is gone. Bye, don't leave. Don't leave. He's now gone to become mango juice.
Habibi, you need a massage there. Your head is moving from side to side.
MK Bobby Naidu, we bobbing.
TK.
ठीक है बराबर चौकस Right, let's go, let's go, let's go, let's go, let's go. Right, the last one, plug it like the way it's on there. Let's answer the last one. Last one. Last one. Don't be stupid. Just be clever. Don't be stupid. Put into your calculator 2 sine 29
Sorry, stop.
plus 4 10 40.
You're giving me a big headache now.
Right. Plug in. Bicep plug in. 2 sine 29 close bracket plus 4 10 40 close bracket equal 4,326, 4,326, which is approximately 4,33. Khalas, take you, done, finish. We are done. We are done. Right. Right. Here we go. There we go. I wish you got it. Right. Let's go. Let's go. Let's go. Let's go. Let's go. Let's go. Right. Well done, Yahya. Well done, Havish. Some of you are not concentrating. You are not concentrating. You will fail. How will you fail? Beautifully, nicely, wonderfully. You will fail. Right, here we go, here we go, here we go, here we go. Right, solve for theta. Now, this is the rough one. Guys, you need to pay attention. Onliners, I see you having a blast there in the comment section. It's going off the hook there. Yes, they will fail with flying colors if they don't pay attention. Right, let's go, let's go, let's go, let's go. Right, now pay attention. Now, this is where you really need to pay attention. These ones were easy. Right, listen, listen. How they say in Zulu or Sutu? Mamela, Baba, mamela. Listen. Right. Sine theta is equal to 2 over 5. So we use the shift key here. So theta, you put your angle is equal to shift sine 2 over 5. That's an easy one. Shift sine 2 over 5. We get our answer 23,578. 23,578. So theta is equal to 23,58 degrees. Theta, alpha, beta, theta is always in degrees. Alpha, beta, theta is never in centimeters, millimeters, or whatever. Alpha, beta, theta refer to angles, and angles are always degrees. Right. Now, if you're not going to pay attention, you're not going to get the next few right, and degrees is the last thing you're going to get at university. Right, let's do number 2. Pay attention. Now, these ones are all now your higher order questions. Pay attention. I'm going to show you how it's done. That was easy. Shh, pay attention. Number 2. 2 sine theta equals 0,6. Your angle is theta. So divide by 2, divide by 2. So sine theta is equal to 0,6 over 2. We divide by 2. You want to get it into standard form. This is what we call standard form. Standard form. So a trig function of an angle must equal to a fraction. That is standard form. Guys, if you're not going to pay attention, you're going to battle with us. Girls. Right. Let's go. So theta is equal to shift sine. Shift sine fraction 0,6 over 2. 17,457. Theta to 2 decimal places. 17,46. Right. Shh. Pay attention. Right. Pay attention. Pay attention. Onliners, don't worry about who's joining and who's leaving. What you need to worry about is whether you're going to pass or fail. Trigonometry. I want to see end of the year. You see how they mature, Sanin? Because now they're still playful. They're still a bit childlike. I wouldn't say childish, childlike.
Sure.
More matured way.
In grade 12, it's a different ballgame.
No, leave grade 12.
Grade
Wait
11.
till they see end of grade 10 when we're doing, because the volume of work, they sit here quiet. They don't, there's no comments coming on the side. It's just do more. We're paying attention. We don't want to go home. Please, sir, do more. Leave them. Let them play for now. They're
Until that
playing.
Exam, that first.
Some of
second
them are
exam.
playing here. Yeah. Don't worry. The hard stuff will come. You will cry. Right. So we're done with number 2. Let's go into number 3. Cos 2 theta is equal to 0,7. Guys, do not divide by 2. That's your angle. If a 2 is in front, you can divide side by side. But you can't divide a side by an angle. So now you say 2 theta is equal to shift cos. Now you say shift cos 0,7. So shift cos 0,7. I get 45,572. 45,572,996. Wait, be careful. Don't clear anything from your calculator. Now divide that by 2. Now you got angle and angle. So now you say theta is equal to answer divided by 2, 22,786. This is a Muslim question. 786,498. So theta is equal to 22,79. You divide here by 2. You don't divide the beginning by 2. You divided in the beginning by 2 here in question number 2. Why? Because you had a coefficient and you had a side and a side, you divide. But here you first calculate the angle. Then you divide by 2. I hope you guys are following. I hope you guys are following. I hope you are following. Yes, we're going to do Euclidean geometry after break. How much time do we have? It's 20 past 12 already. Right. You don't, there's no 2 here in the front. So you say shift cos 0,7 to get that. That's your angle. Now you divide your angle by 2. Divide by 2, divide by 2. You get that. Be careful. Be very, very, very careful with this, guys. Let's do number 4. Let's do number 4. Pay attention, guys. These are all exam questions. Number 4. 4 over 3 tan theta is equal to 3. Right. Question. Is the angle multiplied or divided? No. So we got a 4 over 3 here. So what do we do? I'm just erasing here. Question number 4. Right. We multiply this side by 3 over 4 by its reciprocal to get rid of the 3 over 4. What I do to the left, I do to the right. Times 3 over 4. So tan theta is equal to 3 times 3 is 9 over 4. So theta on its own, we use the shift key on our calculator. Shift tan 9 over 4. Shift tan 9 over 4. Boom, 66,0375. So theta is equal to 66,04 degrees. Why did we multiply? Because it was a coefficient, not an angle. Angle we do last. Coefficient we do first. Right? So we're done with that, done with that, done with that, done with that. Now we're going to do the last 3. Pay attention. These are angles. Angle, angle, and coefficient. Coefficient and angle. We do coefficient first, angle last. Remember that rule. Remember that rule. Coefficient first, angle last. Let's write that rule on the top. Coefficient first, angle. You sort out your angle last. Coefficient first, angle last. Sort out your coefficient first. I'll show you. Let's do you'll see it when we do 5, 6, and 7. Coefficient first, angle last. It's a golden rule. You'll keep it till matric. Coefficient first, angle last. Right, let's go. Shh. Let's do number 5. Is there a coefficient for number 5? No. Cos x plus 30 is equal to 0,5. Is there a coefficient here? No. So angle last. Let's do the angle now. Shift cos 0,5. So x plus 30 is equal to, now you shift to get rid of the cos. Shift cos 0,5, 60 degrees. So now solve for your angle. X is equal to 60 minus 30 is 30 degrees. There we go. We're done. We all okay with that? Onliners, we all right with that? Mustafa? Come on. Your Joyce, coefficient. You're asking what does coefficient mean in grade 10? Allah. Coefficient. You are asking what does coefficient? It's the number in front of the variable. Like if I told you 3x, what's the coefficient? 3. If I put a minus there, if this is minus 3x squared in algebra, that's the coefficient, that's the base. For those of you who don't know what's that called, it's called the power, or it's called the index, or it's called the indice. That is called the coefficient. Right. Let's go. Let's go. Let's go. Coefficient first, angle last. Right. Do you want to try number 6 and 7 on your own? Sort out your coefficient. Divide by 2. Divide by 2. Sort out your coefficient first. Then get your angle. Come on. Do number 6 and 7 quickly on your own. Do number 6. Do number 7. Right, number 6. 210 x minus 45 is equal to 1. Sort out your coefficient. Divide by 2, divide by 2. So tan x minus 45 is equal to 1 over 2. Now your angle, x minus 45 is equal to shift 10 half. Shift 10 a half. Thank you, grade 10s. 26,565. 26,565. So x is equal to, now sort out your angle. Minus 45 will go on the other side as plus 45. 71,565. So x is equal to two decimal places, 71,57 degrees. Please tell me, onliners, you all got that right. Right, let's go, let's go, let's go. Right, well done, Jada. I divided for number 4 and I got the same answer. Yeah, you can divide by 4 over 3, Iman. You could have divided by 4 over 3 on both sides or multiplied by 3 over 4. It's the same thing. If you divide by a number or you multiply it by its reciprocal, it's the same thing. Good. Right, the last one. The last one. Blue minion, well done. You got it right. The last one, let's check the last one. Let's see who are sharp. That means if you got the last two right, means you understood the topic so far. Excellent. Right, let's go. Let's go. 3 sine x plus 30 is equal to 3. Divide the side by 3. What I do to the left, I do to the right. So sine x plus 30 is equal to 3 over 3 is 1. X plus 30 is equal to, now use the shift key, shift sine 1. We know it's 90 degrees. Shift sine 1, 90. So x is equal to 90 minus 30. X is equal to 60 degrees. Oh, 3x plus 30, sorry. Okay, no stress. 3x, 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 3x is equal to 90 minus 30. 3x is equal to 60. X is equal to 60 divided by 3. X is equal to 20 degrees. There we go. Thank you for that. There we go. Guys, you are done with the first half of trigonometry for the year. We got the second half of trigonometry to do. Then you are done with trigs. That's the whole year's trigs. We're going to do that. How's our timing? 12:30. I think it's time for break. Do you guys want lunch now? Or I can start with the second half of trigs now. Lunch. So let's push. Let's push. Asanin, their bellies are screaming for lunch. I say, let's push till 1:15. 20 past. Okay, shame. I feel you sorry. What? Till what? So you got now 30 and 20. You got 50 minutes break. 50. 20 past 1. We will regroup with the second half of trigonometry. Guys, I hope you guys are enjoying the session. Yes, it's lunch. I'll see you guys at 20 past 1. Assalamu alaikum. See you guys in 50 minutes. Testing 1, 2, testing 1, 2. Can you guys hear me now? Can you guys hear? Can you guys hear? Are we good to go? They're still saying no sound there online. Onliners, have we got sound? There we go. We good to go, and we back, guys. We are back. We are back. We are back. Right. We're finishing up the heavy trigonometry. So here we go. Let's finish this. So here we go. Here we go. Here's an exam question. Very, very basic, but let's just see if we can crack this. Hope you guys enjoyed your break. We are back in session. That's 90 degrees. We're going to be doing Euclidean after this. We're going to be doing geometry after this. A, B, C, 35 degrees, and that is 8. Right. Find AB. Question number 1, find AB. All right. Okay. We're going. Just waiting for that. Waiting for the screens to come on. We are streaming. Onliners. Huh? All right. Onliners, can you guys see the screens? Are we clear? I know on-siters, we're just waiting for it to come. So we're going to finish up trigonometry. We're finishing up trigs. I'm taking you up to exam-style questions. And we will be doing geometry. So let's just give it a few seconds, guys, until our screens here in-house come up. And I think we are going live there. Here we go. There we go. There we go. And we are back. No problem, Spectral Pal. If you're still eating, continue eating. No stress. No stress. Guys, this is session 3, round 3. This is amazing. We still got full house. And it's amazing to see so many of you being so activated and so hungry to learn math. Right, so here we go. Find the length of AB and then find AC. Right, 4 marks, 3 marks, total marks, 7. Okay, here we go. Let's get the earpiece right. Last session for today. We see the end. And we're almost done, guys. Hang in there. But there's still quite a bit of work to do. Relax. Before you know it, today is over. But pay attention because this work is important. Shh. Right, let's go. Onliners, we ready? Buckle up. Let's start. Good to be back. Lovely. Number 1. Shh. That's our reference angle. Opposite, hypotenuse, adjacent. Now, I'm going to start off with sine 35 is equal to opposite over hypotenuse because we need to find AB. So you can only have one unknown. So sine 35 is equal to what's your opposite? AB. That's what we need to find. Over hypotenuse, which is 8. I'm putting a tick there. Are you all following? Cretans? You see what I did? Sine 35. I couldn't use tan. If I use tan, it's opposite over adjacent. I got 2 unknowns. I could have either used sine or I could have used cos. But I couldn't use cos because cos got an AC. I need AB. Remember, I need that side and I need another known. So it's opposite over hypotenuse. Now let's make AB the subject of the formula. Multiply by 8, multiply by 8. So AB is equal to 8 sine 35. Remember, we multiply this side by 8. What I do to the right, I do to the left. So AB is equal to 8 sine 35. The angle is given. Do I need to use the shift key? No. 8 sine 35, close brackets, equals, I get 4,588. 4,588. So AB is equal to 4,59. So AB is 4,59. And there we go. We got our first 4 marks. You will answer it in your exam exactly the way I've answered it here. I'm not doing rough calculation, copy and paste. Please learn this, guys. Now let's find AC. Now we got a side, we got another side. Whether you want to use trigonometry or you want to use Pythagoras, it's entirely up to you. What do you want to use? I say let's use trigs. A over H is cos. From Sohcahtoa, A over H is cos. I'm going to go cos 35 is equal to A over H. So cos 35, according to Sohcahtoa, A is AC over H is 8. AC again on its own. We're making AC the subject of the formula. Times 8. Times 8. So 8 cos 35. So AC is equal to 8 cos 35. AC is equal to. Let's go. So we're learning how to solve a triangle using trigonometry. So 8 cos 35, close brackets, 6,55. Again, I'm telling you, whether you use Pythagoras, because you got 2 sides, whether you use Pythagoras or whether you use trigonometry, guys, you get exactly the same result. Same answer. All right? There we go. Right. Now let's do trigonometry in real life. So if you have a boat and you have a mountain and you got a boat in the ocean and you want to now calculate what is the distance between either the boat and the mountain, the height of the mountain, or the boat and the top of the mountain. So let's do now a trig problem in real life. Okay, here goes, guys. I hope you've all taken this down, and let's try a trig problem in real life. Okay. Now, something that's important in trigs to remember is what we call the angle of elevation and the angle of depression. Right. Some of you are suffering from the angle of depression, but for now. But relax, we're going to elevate you. Right. Can I clear here? Right. Shh. Let me explain to you what is elevation and depression. Right. Say there you are, and you're looking straight ahead. Now, when you're looking straight ahead and up, that angle is called the angle of elevation. When you're looking straight ahead and then you start looking down to a point, that point is called, that angle there. So let's call beta. Angle beta is the angle of depression. Angle alpha is the angle of elevation. So elevation and depression, when you're looking straight ahead up, angle of elevation. The whole angle is not called elevation. From the bottom to the top. It's only from where you're looking straight ahead, up, elevation. Where you're looking straight ahead, down, depression. Make a note of this important concepts. Important concepts. Many of you guys in the chat box, don't worry about the comments. I know you guys are all starting up a WhatsApp group or something like that. You guys been chatting for the past hour. Don't worry about that. Worry about this work. Otherwise, you're going to be in trouble in the exams. So these 2 concepts, the angle of elevation, angle of depression, are very important concepts. You're going to see it in the next question. Right. You've got Elevation, I think we all understand elevation, looking straight ahead up, looking straight ahead down, that is depression. Right, here goes. Pay attention, pay attention. Right, so you've got the ocean and you've got a mountain. The cliff is H, and we know that is 90 degrees. And then you've got a boat here. And you got a dude standing there on the boat. Right. Now, he wants to find out, he knows, he wants to find out what is the distance. Say the distance between him and the top of the mountain is 200 meters. The cliff height, we don't know, but we know that the angle between where he's looking and the ocean is, let's say, 42 degrees. Find the height of the mountain, or find the distance between the boat and the cliff of the mountain. Find the distance between the boat and the base of the cliff. So here's trigonometry, there's a right angle triangle. Here is a right angle triangle. And we know that that angle there is 42 degrees. There we go. We need to find that side. So which trig function will I use? That's opposite, right? Remember, this is h the height, not h the hypotenuse. With regard to this angle, that's your opposite side. That is your hypotenuse. And that is your adjacent. So the distance between the boat and the base, is which one? Adjacent. So which trig function will I use? A and H. So from SOHCAHTOA, which one is it? A and H. Yes, very good. SOHCAHTOA. So it would be cos. So cos 42 is equal to A over H. Cos 42 is equal to your adjacent, that's what we're looking for, over your hypotenuse, not h the height, h your hypotenuse over 200. So A is equal to 200 cos 42. And here's a real life example, 200 cos 42, plug it straight into your calculator, you get 148,62. 148,62 meters. So the distance between the boat and the base of the cliff is 148,62 meters. There we go. There we go. Okay. Let's look at another example. One more real life example. One more real life example. Okay, here goes. Okay. Let's go. Let's do this one. You've taken it down. Can I clear the frame? Onliners, can I clear the frame? 148,6, 148,62, it's fine. Right, here goes. I'm clearing the frame. Let's take another one. Here's the boat. There's the boat. That's the surface of the water. Right. And let's say from the boat, and let's say here at the bottom of the ocean, there's treasure. Right. Treasure hunters in a boat at point A detect a treasure chest at the bottom of the ocean at an angle of depression. Okay. So the treasure is at the angle of depression. Listen, angle of depression. Angle of depression of 13 degrees from the boat to the treasure. From the boat to the treasure. Right. They sail for 80 meters. They sail for 80 meters until they are directly above the treasure. Sail 80 meters until directly above the treasure. Pay attention, guys. Right. Calculate the depth of the treasure from the boat. Calculate the depth of the treasure from the boat directly above the treasure. Directly above the treasure. Now you need to draw a diagram. This is where the boat is. This is where the treasure is. That's the treasure. So let's look at the information. Take this diagram down. Take this diagram down. Onliners, I hope you guys are paying attention. I hope you guys are paying attention. This work is very important. Right. Let's go, let's go, let's go, let's go, let's go. Right. So the boat is here. So all we're going to do, we're going to draw a line from there to the treasure. And then we're going to draw a line there. And that's going to be 90 degrees. This distance here is 80 meters until they are directly above. So they travel for 80 meters. The angle of depression from the boat, so where you're looking straight ahead down, so that angle there is 13 degrees. So that's how you construct your diagram. Right. Calculate. So let's call this point A, B, C. So they want calculate the depth of the treasure from the boat directly above. That means what length do they want? They want BC. They want BC. So now that's your opposite. That's your hypotenuse. That's your adjacent. We need BC and we need 80. So opposite and adjacent from SOHCAHTOA. Opposite and adjacent is which function? Sine, cos, or tan? Tan. So here we go. Tan 13 is equal to opposite over adjacent. Tan 13 is equal to, what's your opposite side? BC. Over what's your adjacent? 80. We now need to solve for BC. So BC is equal to times this side by 80 times that side by 80. What do I have? 80, 10, 13. And here's your final answer coming up. 80, 10, 13. 80, 10, 13. Close brackets equals 18,469, 18,47. 18,469. 18,47 meters. So the depth from where the boat is, so say the boat will arrive there, and the depth between there and there, we know it's probably 18,47 plus minus 20 meters deep to the treasure. And that's how we use trigonometry in real life. Now, I just want to quickly go over, let's look at our timing, 1:45. So we're going to push from 1:45 to 3 o'clock. I just want to show you one last component. I want to show you a last component. Right? Once you get to school, now that you understand trigonometry, now you can work with your past papers. You can understand your teacher. You know what they are talking about. There's two more components. One where they teach you the Cartesian plane. Your teachers will show you that at school. But at least you have a very good understanding of what trigonometry is all about. We have what we call let me just quickly end up here. We're doing what we call the reciprocal functions or opposite functions. Pay attention to this. Here goes Yahya, 18,47. Well done. Chelsea, you were using 10. Well done. Dayan, 18,46. Fantastic. Felicitas, well done. Nabila, 10. Well done, well done, well done, well done, guys. Well done. At least you got understanding trigonometry. Okay, can I erase this? Can I clear the frame? Good, let's go. Right. We're doing what we call reciprocal function. Let me teach you how to deal with reciprocal. Reciprocal means opposite. Reciprocal functions. Pay attention. Right. Now you have three new functions. So you do have sine, cos, and tan. And that's what your calculator has. Shh. We have what we call cosecant, secant, and cotangent. Right. Let me just write it out. Cosecant, which is called cosec. Secant, which is called sec. And cot, which is cotangent. Pay attention. Right. What is cosec theta, sec theta, and cot theta? These are the opposite of these three. Pay attention. Shh. Cosecant is 1 over sine. So cosec of theta is 1 over sine theta. Learn. Secant is 1 over cos theta. Learn. And cotangent is 1 over tan theta. Learn. Right. These are what we call our reciprocal because they are the opposite function. The word reciprocal means opposite. I'm going to show you how to deal with this in your exams. Very similar to sine, cos, and tan, but your calculator doesn't have cosec, sec, and cot. It's only got sine, cos, and tan. So we need to convert it from cosec, sec, and cot from our question to sine, cos, and tan so we can use our calculator. Your calculator does not have cosec, sec, and cot. Right. I'm going to write it here. Calculator does not have reciprocal functions. So you first need to convert. And second, you need to solve. So first you convert, then you solve. First convert, then solve. Guys, these are very, very, very important pieces of information that I'm giving you here. I hope you're taking it down and you will refer to these notes in school or in class. Right. Pay attention. Pay attention. So let's quickly go through this again. Cosec is 1 over sine. Sec is 1 over cos. Cot is 1 over tan. These are what we call our reciprocal functions. So when your teacher talks about reciprocal functions, you know exactly what they're talking about. It's a quick topic, guys. It's not difficult. It's a quick topic, but it's examinable. You will see it in your exams. Only for grade 10. You won't see it in 11 and 12. So it's only for you guys. Reciprocal, grade 11 and 12, you only see sine, cos, and tan. Grade 10, you are introduced to the reciprocal functions. Okay, guys. Stay with us. Stay with us. All right, here goes. This is how the, right, now that you've taken this down, let's go into reciprocal functions and let's see how you solve reciprocal functions. Right, you've all taken this down? Come on, guys, we need to work fast. Can I erase? Right, here goes. Shh, pay attention. Here goes. Right, solve for theta. Solve for theta. And they tell you that cosec theta is equal to 2. Shh. Quiet, quiet, quiet. Now we need to solve for theta. For 3 marks. Question in your exam, answer. Pay attention, girls. Shh. Let's go. Okay, you guys ready? You guys ready? Right, let's go. The first thing we need to do is convert that. So cosec theta is 1 over sine theta is equal to 2 over 1. Cosec is 1 over sine. Now we need to solve for theta. So flip this side, flip that side. So sine theta over 1 is equal to 1 over 2. So theta is equal to shift sine a half. Now you use the shift key. Shift sine 0,5 or 1 over 2. And that's your answer. Shift sine 0,5 or half, 30 degrees. And there we go. We've solved for theta. Convert, then solve. Convert, then solve. 2 parts. 2 parts, guys. Convert, then solve. Let's see you guys do this one. Sec theta is equal to, or let's say 2 sec theta is equal to 10. Solve for theta. Do this one here on the side. Divide by 2 first. I'm just helping you along. Come, guys. Come, guys. Let's go. So sec theta will equal to 10 divided by 2 is how much? 5. So 1 over cos theta. Remember, sec is 1 over cos. Is 5 over 1. So cos theta over 1 equals 1 over 5. Theta is equal to shift cos 1 over 5. (78.46 degrees. If you want to round it up, you can even round it up to 78.5. And there we go. Learn. And let's throw you into the deep end with one last one with reciprocal function. It's almost identical to sine, cos, and tan. Only thing we got to convert first. Right, here goes, here goes, here goes, here goes, here goes. Last one. Right. cosec 2 theta plus 10, and let's make this is equal to, let's make that 20, and let's make that 2. There we go. Right. Solve for theta for 5 marks. Solve for theta for 5 marks. Now, the first thing we need to do here is get rid of this 2 in front. Remember, get rid of the coefficient, then solve. But in this case, get rid of the coefficient, convert, then solve. Get rid of the coefficient, convert, then solve. Right, here goes. Well done, Nabila. Well done, Rishail. Rishail. How do you pronounce your name? Rishail. Havish. Well done. Spectrapel. Well done. Right, let's see. How sharp are you guys? Come. This is an exam question with reciprocal functions, and that is going to wrap up trigonometry for now. So you're done with 90% of trigs. You guys only got one more component, which is the Cartesian plane to do at school. Your teachers will show you that, and you are fully prepared for your final. I mean, this is the whole year's trigs that we've completed. Well done, Rishail. Good. Lovely. Right, let's see. Guys, like I said, you are done with 90% of trigs for 2024. %10 is the Cartesian plane, which your teachers will show you at school. But as long as you guys have a good understanding of trigs. Right, here goes. Let's do this. Quiet. Right. So divide by 2. So we left with cosec 2 theta plus 10 is equal to 20 divided by 2 is how much? 10. Now 1 over sine 2 theta plus 10 degrees is equal to 10 over 1. We want this on the top, so sine 2 theta plus 10 is equal to 1 over 10. We flip this side, we flip that side. 2 theta plus 10 is equal to, now we apply our shift key. So shift sine 1 over 10, shift sine 1 over 10 gives me 5,739, 5,74. 2 theta is equal to 5,74 minus 10. 5,74 minus 10 minus 4,26. And theta will equal to minus 4,26 divided by 2. Minus 2,13. And there we go. How many of you got that one right? How many of you? I didn't see anybody on the, oh, I didn't see anybody there on the onliners getting it right. Right. Nabila got it right. Well done. Farhan. Subada, you got it right. Negative 2,13. Spectrapel, you were close. Yahya. All right, good. Right. And there we go. We are done with trigonometry. We are done with 90% of trigonometry for the year. I hope by the time Mr. Charles and the other teachers here get started with trigs, you guys will be flying through trigonometry for 2024. Guys, there we go. We're done with 90%. Let's do this. Let's start now. How much time do we have? We got about just on an hour. Let's go into Euclidean. Let's go into Euclidean geometry. Right, so I'm going to start off with all the stuff you need to know. Quiet. Cretans. Right, here goes. Right, let's start off with Euclidean geometry. Right, let's start off with Euclidean geometry. Right, under Euclidean geometry, you want to... Shh, quiet. Thank you, grade 10s. Grade 10s, I'll wait for you. Why do we have geometry? Again, we have geometry because we want to solve angles, or we want to solve sides, or we need to prove. Right. That's why we have what we call laws, and our laws are called theorems. Shh. Right, grade 10s, too much talking here. Right. Geometry is very easy. I know many of you find it very difficult. But you just need to understand your basic laws, and you need to start from the known, what's given, and then move to the unknown. Using your laws as reasons, using your theorems or your laws as reasons. So we always start, guys, you always start with the known, moving to the unknown. You'll see, if you follow this train of thought, you won't have a problem in grade 10, 11, and 12. You'll actually love this topic. Now, so in geometry, you're either solving angles, you're solving sides, or you're proving. That's it. That's all you are doing. Angles and lines, angles and lines, angles and lines, but there are relationships between them. Right, here goes. Right, let's go, let's go, let's go, let's go, let's go. Right. The first law that we need to know, pay attention. I'm doing right from whatever you know about lines. The first thing we need to know about lines, we know that that side is called obtuse because it's greater than 90. And if we're counting from this way, it's called acute, which is less than 90. We know acute plus obtuse, this angle here, plus that angle there, the star plus the tick, is equal to 180 degrees. And what do we call that, guys? Angles on a straight line, yes or no? But mathematically, what do we call it? Adjacent. Adjacent means next to each other. Supplementary means they add up to 180. That's your first law. Second law. Please pay attention. So if I gave you that, and say I gave you that, and I call that 1, 2, 3, we know that angles around a point, angles around a point add up to how much? 360 degrees, and 360 degrees is what we call a revolution. Right, quiet, a complete change. A revolution. Shh. Important concepts, guys. I'm going through everything that you need to know up to grade 10. Then we're going to apply it to scenarios. We're going right up to the midpoint theorem. Many of you have not done it in school. But midpoint theorem and parallelograms are what's going to be tested in your June exam and finals. So I'm taking you from ground zero to hero. Hopefully, in 1 hour on the dot. We will not go beyond 3 o'clock. We will wrap up at 2:58 and 32 seconds. Right, let's go. Pay attention, pay attention, pay attention. Right, I'm clearing the frame. Now, the next theorem you need to know, the next law you need to know, the next concept you need to know. Pay attention. That's 1, that's 2. And let's call it angle A. Angle A1 is equal to angle A2. We all know that is what we call vertically opposite angles. And vertically opposite angles, what are they? They are equal. Angle A1 is equal to angle A2. And if this was called angle A3, and that was called angle A4, angle A3 will also equal to angle A4, which we call vertically opposite angles, and they are equal. Pay attention, take this down. This is exceptionally important. Right, pay attention. Right, we need to know triangles. If two sides are equal, what type of a triangle is that called? Very good, it's called an isosceles triangle. And what is special about an isosceles triangle? Triangle ABC. Angle B will equal to angle C. Angle B will equal to angle C. And what's the reasoning for that? Not isosceles triangle. Angles opposite the equal sides. Angles opposite the equal sides of an isosceles triangle are equal. The next law you need to know. We're going through it law for law. Shh, girls, you need to be paying attention. This work is super important. Right. When three sides are equal, what type of a triangle is that? Yes, very good. That's an equilateral triangle. And what do we know about an equilateral triangle? Each angle is equal to 60 degrees. Why? Because sum of angles of a triangle add up to 180. The angles are also equal. Equal angles. So each angle is 60 degrees. Sum of angles of a triangle add up to 180 degrees. So 180 divided by 3 is equal to 60. Right. We're going through it step by step, and I'm going to build you up to a model, to a very complex. We're starting from the laws, from the basic, refreshing your memory of everything you've been taught from grade 7. Some of these laws were taught, remember, in grade 10, you will be using grade 7, 8, 9, and 10 theorems. When you get to grade 12, you'll be using all the years, from grade 7 to grade 12. Right. Please take this down. Here we go. Here we go. I see some of the learners there in the chat box there, Hasanain, I think they need to be put into detention. They're not paying attention. Some of the learners, because they just... Guys, you are distracting the learners. You are distracting the learners that want to learn. Guys, if you are still there in the chat room and you're just going on for yourself, of course, let's focus on the lesson. That's what you're here for, otherwise you've just wasted your Sunday, guys. Right, so we're done with up to number 5. The next one we need to know. The next one that we need to know, number 6, very important. In any triangle, the exterior angle of a triangle, let's call that B1, B2. Let's call that angle A. Let's call that angle C. Angle B2 is equal to angle C plus angle A. Angle C plus angle A. So if this is 100 degrees and that is 20 degrees, then how much is angle A? You'll start it like this. You'll say 100 is equal to 20 plus A, and this is an equation. A is equal to 100 minus 20. A is equal to 80 degrees. And what is the reason for this? Exterior angle of triangle is equal to the sum of the interior opposite angles. Please learn to justify the way you move. Now, if you're not going to take down all these theorems, when I start throwing you into the deep end, you're not going to know what's going on. Okay, here goes. Here goes. Here goes. Number 7. Right, so we're done with triangles, we're done with isosceles, we know sum of angles of a triangle, we know exterior angle equal to sum of interior opposite. Pythagoras, 90 degrees, you need to know. Right. Shh. Now comes the interesting one, which is heavily used. Parallel lines. FUN. Corresponding, alternate, and co-interior. Very important. Then we're going to do congruency. You have to know congruency. Then we'll do some up to grade 9, what we call riders, RY. A big problem is called a rider. In geometry, it's called a rider, RYDER. They call riders. They're there to ride your brains. Right, here goes, here goes, here goes. I'm clearing. Right, let's go into number 7. You got to know all your rules with regard to parallel lines. And here goes. So if we have two parallel lines, for example, going like that, and we have a line crossing over, that line is called a transversal. Pay attention. So if this is A, A1, A2, A3, A4, that line is parallel to that line. And this is angle B1, B2, B3, B4. We know the F shape that way, on the same side of the transversal, both below or both above. Upside down, so we call that corresponding. Corresponding angles, quiet, are equal. It's the F shape. Angle A2 is equal to B1. A2 is equal to B1. A1 is equal to B4. A3 is equal to B2. And A4 is equal to B3. These are all our F shapes. F going that way, F in the opposite, F upside down in each of the directions. So it doesn't matter in which way the F shape is, same side of the transversal, both up, both down. That's why it's called corresponding. They both above or they both below. And they are equal. The next one we have is the U shape. The U shape, so that is parallel to that. One below, one above. Same side, one below, one above. So angle A1 plus angle B1, there's the U. A1 plus B1 is equal to 180 degrees. We call that co-interior angles, and they're not equal. They add up. They are supplementary. They add up to 180 degrees. Supplementary. They add up to 180 degrees. Co-interior angles. So A1 plus B1, A4 plus B2. Angle A4 plus angle B2 is equal to 180. Co-interior. Angles add up to 180 degrees, or they are supplementary. Then we have the last one, which is the N shape or the Z shape, F-U-N, fun. One below, one above, on the opposite side of the transversal. We call that alternating or alternate angles. And they are equal. So corresponding is equal, alternate is equal. Which are your alternate angles? Your Z shape here. A1 is equal to B2. A1 is equal to B2. A4 is equal to B1. Alternate angles equal. There we go. Right. I'm just going through all your theorems quickly. So take that down. What else do you need to know? What else do you need to know? Congruency. You remember? Congruency. Right. Here we go. Here we go. Here we go. Okay. Right. Let's quickly recap congruency from grade 9. Right. There are 4 laws of congruency. Who remembers the 4 laws of congruency? S, side, side, side. Right. So wait before you go there. Let's just draw what SSS looks like. SSS, one side equal to one side, another side equal to another side, and the last side equal to the other side. Therefore, their corresponding angles will be equal, right? Side, side, side. Then we have side, angle, side, but it must be the included angle. The angle between the two sides, like this. So, you got a side of this equal to a side there. You've got a side here equal to a side there. And you have that angle there equal to that angle there. You can't have it anywhere else. It's got to be the included angle, the angle between the two sides. Right, so that's side, angle, side. What's the next one? Angle, side, angle. So angle, side, angle would look like this. 2 angles and any side. 2 angles and any side. So side, 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 angle, side, angle, side, angle. And who remembers what's the last one? Yes, you're so smart. Right angle, hypotenuse, side. She remembers. Right angle, hypotenuse, side. So we'll have a 90-degree triangle like that. We'll have a 90-degree triangle maybe going like that. Right angle. So there's your 90 degrees, hypotenuse, side. There we go. This proves congruency. What does congruency mean? It means that they are identical. It also means that because they are identical, their corresponding sides are equal and their corresponding angles are also equal. Okay. Now, let's start with a question from, let's start with a grade 9 question. Before we actually start with the grade 10 Euclidean, which is the midpoint theorem and parallelograms. We're moving on good time. We're moving on fantastic time. It's going for 20 past 2. We're into the last 40 minutes and we're done for the day. So we're moving towards the end now, guys. What you want to do is pay attention here. You want to pay attention so that we can work well towards the end and you can pat yourself on the back that you've sat for 2 days boot camp in math. More math than you ever have done in your life in 2 days. Right, here goes. Take this diagram down. I'll give you that. I give you that. I give you this. I'll give you that. There we go. Pay attention. That side is parallel to that. This is F, A, B, C. That's 8x. That's 4x. That's 80 degrees. That's angle Q. That point is E. That is Z. And that is P. This angle is 8x. Right. And this angle is Y. Right. In triangle ACF, AF is parallel. So AF is parallel to BE. Right. Find all the small letters. I want you to find P, Z, Q, X, Y. Right. With reasons. With reasons. I've just put a line through the Z so you don't confuse it with a 2. That's a Z. Small z. Again, we start with the known moving. Which is our known there, guys? Which is the one that's given? Which is the one that you cannot contest? The 80 degrees, am I right? That's your known. Start from your known, moving to your unknowns. And always start with the unknowns that are closest to your known. The known is 80. It's a given. You know its value. Unknowns, these are unknowns. Unknown, 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 unknown. The known is the 80 because it's given. It's known. Right? Let's go. Right, here goes, here goes, here goes. We start off with Q. I'm going to start off with Q. So I'm going to say angle Q plus 80 degrees is equal to 180 adjacent supplementary. Therefore, angle Q is equal to 180 minus 80, which Q is equal to 100 degrees. So we got Q is 100. Now, the minute you get an answer, take your answer and put it on your diagram. It will help you to move to the next point. Which other angle can you relate to the 80? How about Z? The F shape corresponding. Angle Z is equal to 80 degrees corresponding. So Z is 80. Right. Now, I want you guys to try. Come, I'm going to give you guys a couple of seconds to try and figure out P, 4x, P, B, C. I want Y, I want X. Let's see. Come, apply your minds. Apply your minds. I know you guys are brain fried. That line is parallel to that line. AF is parallel to BE. Let's go, let's go, let's go, let's go. Yes, AF is parallel. If you see the two arrows on the lines, the arrow on the line indicates that these two lines are parallel to each other. I would go for X first. If I solve X, I can solve Y and I can solve P. So watch this. I'm going to go this way. Exterior angle is equal to, here's a triangle. So let's do this. There we go. That, and that. Exterior angle is equal to the sum of the interior opposite angles. So I'm going to say 8x is equal to 4x plus 80. Because the exterior angle is equal to the sum of the interior opposite angles. So 8x minus 4x is 4x is equal to 80. X is equal to 80 divided by 4 is 20. So x is 20. So if x is 20, how much is 8 times x? 8 times 20, that means that angle there is 160. Therefore, angle Y, angles on a straight line, Y equals 180 minus 160, adjacent supplementary. Y is equal to 20 degrees also. Y is 20. 4x, angle B, is equal to 4x, which is equal to 4 times 20, which is 80 degrees. That angle there is 80 degrees. And that angle and angle P are corresponding. So angle P is also equal to 80 degrees, corresponding. And there we go. We've solved the entire diagram. We got P, Z, Q, X, and Y. You'll get about 8 to 10 marks for this. You will get about 8 to 10 marks for that. Okay. We're now going on to a grade 10 concept, which is called, yes, you can. No problem, Avish. You did sum of angles of a triangle equal to 180 degrees. No problem. No problem. Right. We're doing the grade 10 concept, which is called the midpoint theorem. Very important. Pay attention. Right. Grade 10s. Right. Here goes. Now here's your grade 10. So all this here was up to grade 9. This was all up to grade 9. I'm just having a look here. Okay. Nothing else there. Right. Give me a second. All right, here goes. Midpoint theorem. Put the heading there, the midpoint theorem. The midpoint theorem. Right, watch here. Let me explain to you. Right, so we're now doing grade 10. This is grade 10 Euclidean. The midpoint theorem. Right. The midpoint theorem states that in any triangle, ABC or PQR, listen. Right, we're talking about this red line now. We talk about that line there. If a line goes from the midpoint is drawn from the midpoint of one side to the midpoint of another side. What is important about it? What is special about it? Listen. Shh. Take this theorem down. It's important. Because when I throw you into the deep end with an exam question now, with regard to the midpoint theorem, you're going to need to know how to do it. Right. If a line, we talk about the red line, DE. If a line, the line we're talking about is DE, is drawn from the midpoint of one side, the midpoint of one side of a triangle to the midpoint of another side, of its opposite side, to the midpoint of its opposite side. Grade 10s, you need to pay attention. Right, then what is special about it? There's still too much talking here, girls. Right. If a line DE is drawn from the midpoint of one side to the midpoint of the other side, it becomes parallel to the third side. It's parallel to the third side. And not only is it parallel, and it is half the third side in length. Pay attention. So that means if this is 100, then that must be 50. So not only, so if a line goes from the midpoint of one side to the midpoint of another side, it becomes parallel to the third side and half the third side in length. Right. Now you're going to be introduced to a new word today called the converse. Converse, not all-star. The converse meaning the opposite. The opposite of the theorem also applies, and we're going to do that now. So this is midpoint. Midpoint to midpoint. Grade 10s. Midpoint to midpoint. Parallel to the third side, half the third side in length. That's midpoint to midpoint. That's the theorem. I'm going to say it again. Midpoint to midpoint. Parallel to the third side, half the third side in length. But the opposite, the converse also applies. Hear me out, guys. The opposite, right. Watch here. Watch here. So this here is midpoint to midpoint becomes parallel to the third side and half the third side in length. Right, now let's do what is the converse of this theorem, the opposite of the theorem. Girls, I hope you guys are paying attention here. This is very important work. Right, I'm just going, let's open up a new frame. Here is the converse of that same theorem. Watch here. Now we have a triangle. And we got a line. And it's drawn from the midpoint of one side, and they tell you it's parallel to the third side. That's the converse of the midpoint theorem. Converse of midpoint theorem. Now what's given? What's the difference between the first case and this case? The first case, the line was midpoint to midpoint. Am I right? Guys, grade 10s. It was midpoint to midpoint. This one, it's midpoint and parallel. That's the difference. This one, now they tell you it's drawn. This line is drawn from the midpoint. And they tell you it's parallel to the third side. Now, the converse states that it must go to the midpoint of its opposite side. So here goes. Here's the converse of the theorem. If a line is drawn from the midpoint of one side, there we go, from the midpoint of one side, drawn from the midpoint of one side parallel to the third side. Parallel to the third side bisects means cuts in half, goes to the midpoint, cuts in half, or goes to the midpoint of the opposite side. You're going to see exactly how this is now. When I start now with the exam questions, you'll see how it will be tested. Midpoint theorem will be tested and converse will be tested. Of the triangle. So there we go. That's the converse. The original theorem states midpoint to midpoint, midpoint to midpoint, parallel and half. The converse states midpoint parallel must go to the midpoint of the opposite side. Very important. Very, very important. So just remember, guys, grade 10s, midpoint to midpoint is midpoint theorem, parallel and half. But midpoint parallel given is the converse of the midpoint theorem. That's the reason you will use. Pay attention, you're about to be thrown into the deep end. Right. Here goes, here goes, here goes. Yes, it's Jamboard. Google Jamboard. They're wondering what am I drawing on. Yes, Google Jamboard. Right, let's go, let's go, let's go. But I believe Google Jamboard they're cancelling it by the end of October. So you have to use another, we're going to have to find another Jamboard to use. You know that. Google Jamboard is being obsolete. They're cancelling it, bruh. Right, so let's go, let's go, let's go, let's go. So you've taken it down. You've taken it down. You've understood it. Let's throw you into the deep end. So here's a grade 10 exam question. Right, pay attention. So here goes. So they give you something like that, that, and they give you that, and they give you that, and they give you this. Pay attention. A, B, C, D, E, F. A, B, C, D, E, F, and G. Right. In triangle ACD, now you know you got a big triangle, you got another triangle here, and you got another triangle there. So you got ACD, ACE, FBD, or DFB. You got three triangles there. So they tell you in triangle ACD, AB equals BC, GE equals 15 centimeters, AF equals FE equals ED. This is all given to you. Find the length of CE. Find the length of CE for 6 marks. Find the length of CE for 6 marks. Here goes. Right, take this down, guys. Take this down. Take this down. We're going to do 2 examples of midpoint theorem. Then we're going to do a parallelogram. And that should take us to the end, guys. We're already 25 to 3. The last 25 minutes and we're done. We're at the end, guys. Okay. Let's go. Take this down. Right, now it's very important that you guys follow me and we do it all together. Right, are you guys ready? Come. Just take it down. Just take it down. I'll do it for you. because we don't have time. I'd love to let you do it by yourself. Right. Now, let's first put in what is given to us. AB is equal to BC. So AB is equal to BC. You indicate it by one line, one line. GE is 15. GE is 15. Right. AF is equal to FE. Where's AF? AF is equal to FE is equal to ED. Right, there we go. Now, all I've done is I've thrown in all the information that was given to us. Find the length of CE. They want this big length here. So firstly, guys, in my answer, I'm going to look at this triangle here because I see the midpoint there. I see midpoint to midpoint. See here. This line here is drawn from the midpoint to the midpoint. Yes or no? So what theorem is here? So you start it like this. In triangle ACE. Right. BF. So we know that AB is equal to BC given. We're not proving congruency. We're just telling the person who's marking how we're proving the midpoint theorem. AB equals BC. AF equals FE. Given. Now, what can we conclude? Therefore, BF is parallel to CE. There we go. We've just now proved that that is parallel to that. Why is there an echo here? I'm picking up an echo, no? BF is parallel to CE, and also BF is half of CE, and BF is also equal to half of CE, and that is what we call the midpoint theorem. Midpoint theorem. That's the reason that we put. So we're done. Now, what's important is that we proved it to be parallel and we proved it to be half. They want this side. Remember, they want CE. They want the whole length of this big line. Now, let's look at another triangle. Watch here. Let's look at this triangle here. Now we got midpoint and we got parallel. So this is the converse of the midpoint theorem. Right, pay attention now. So this was the midpoint theorem. We are now going in triangle BFD. In triangle BFD. Right, FE or EF is equal to ED given. And now we just proved that BF is parallel to GE. Proven. We just proved it in there. Therefore, what does that make? What's the relationship? That means GE is half of BF. Therefore, GE is equal to half of BF. And that is the converse of the midpoint theorem. Converse of midpoint theorem. Right. So how much is BF? Therefore, BF is equal to, if this is 15, how much must BF be? 30. BF is equal to 30 centimeters. Right. Now we got this as 15. We got that as 30. They want the whole of CE. They want the whole of CE. Now, isn't this half of that from the big triangle again? We proved midpoint to midpoint is parallel and half. Now we go back to triangle ACE. Therefore, CE is equal to 2 of angle BF, midpoint theorem. Angle CE is equal to 2 times 30, which is equal to 60 centimeters. I saw somebody giving the answer there very fast earlier on. Lovely. Leila got it. Havish got it. Fantastic. Fasia's got it. Many learners there before have got it as well. Suraya had it as CE as 60. Fantastic. Well done. I'm glad you people seeing how to apply the midpoint theorem. That's your final answer. You'll get about 6 to 8 marks for this. 4 marks here, 4 marks there at least. Right. G. Yeah. Why? Which one? That one? I'm good. Yeah. Okay. Here goes the next one, guys. The next one. Well done. I hope you guys are seeing. Remember, the only thing I did here, midpoint to midpoint, is midpoint theorem. Parallel and half. But midpoint parallel goes to the midpoint of the opposite side. Watch the next one. In fact, this might be the last one. Let's check our timing. Whoa, this looks like it's going to be almost the last one we're going to do. So here goes. Come, guys. We're almost there. Right. Take this one down. Shh. We got that. We got that. We got that. There to there. There to there. Here to here. There to there. AEB. FC, GD, right? In triangle ABC, right? They tell you AE is equal to EB. Thank you, grade 10s. EF is parallel to BC. FG is parallel to CD. Prove that AG is equal to GD. 8 marks. 8 marks. Okay. Let's go. I hope you all took that down. Before you know it, we are done. Before you know it, we are done. Right. Right. Let's include what's given. AE equals EB. That. AE equals EB. EF is parallel to BC. So the minute they say parallel, put your arrows on the line. FG is parallel to CD. FG is parallel to CD. Prove that AG equals GD. So prove that AG equals GD. That's what you need to prove. You need to prove that that is equal to that, or that G is the midpoint of that line. Right, so let's go. Let's go. We got 2 triangles. I'm going to start in triangle ABC. In triangle ABC. AE is equal to EB. AE is equal to EB given. EF is parallel to BC, given. Therefore, listen to this, watch here. We can now conclude, so this is midpoint parallel, must go to the midpoint of its opposite side. Therefore, AF is equal to FC, converse of the midpoint theorem. Now, obviously, once you understand the theorem, your teachers will now give you more examples in class, or your tutors, and you'll be working through past papers, but at least you'll understand what this concept of the midpoint theorem is. Just remember again, midpoint to midpoint, parallel and half. Midpoint parallel must go to the midpoint is the converse. Agreed? Right. Now we go into triangle. Now we're done with that triangle. Now I'm going into this triangle here. We just proved that that side was equal to that side. And now in this triangle, we know that that line is parallel to that. So again, this here is the converse. So let's go in triangle ACD. AF equals FC given. FG is parallel to FG is parallel to CD given. Therefore, we come to our answer, we come to our conclusion, what they wanted us to prove. Therefore, AG equals GD. That's what they wanted us to prove. And the reason for that is converse of midpoint theorem. How much time do we have? 12 minutes. Yes, we've got 12 minutes left. We got 12 minutes left. Let's throw you. Come on, let's do one more. Let's do one more with a parallelogram. Come on, man. How about we do one more with a parallelogram? Come on, we at the end, guys. Well done, Layla. Well done, well done, well done. Layla is on fire. Right. Right. Let's go, let's go, let's go, let's go, let's go. Let's clear the frame. You'll get 4 marks there and 4 marks here. 8 marks. Let's see if you guys can solve this one with regards to a parallelogram. You guys all know what's a parallelogram. Opposite sides are parallel. Opposite sides are equal. So let's go. Let's go, let's go, let's go, let's go. Can I erase here? Can I clear? Good. Last one for today, guys. Last one and we're done. Hang in there. Hang in there. So here goes. There we go. You guys have been amazing. 2 days. We are like family. Right, here goes. P, Q, Q1, Q2. That angle is X. That's angle E, E1, E2, E3, R1, R2, and S. Right. They tell you PQRS is a parallelogram, a PAM. You know, PAM is the abbreviation for parallelogram. Right, quiet. PQ is equal to PE. QE is equal to QR. ER is equal to SR. PQE is equal to X. Find the size of QER. Find the size of QER for 6 marks. We're at the end, guys. That's E there on the top. That's E. Question, answer. Let's see. We're working according to time. Right, let's go. PQRS is a parallelogram. That means that side must be parallel to that side, PQRS, and that side is parallel to that. We know that this whole side is equal to that whole side, and that side is equal to that side. Shh. Thank you, grade 10s. We at the end. PQ equals PE. PQ equals PE. That piece. Okay. PQ equals PE. QE equals QR. QE equals QR. So if QR is 2 lines, that's also 2 lines. ER equals SR. ER equals SR. That's 1 line. That's 1 line. ER equals SR. Find the size of QER. QER. They want that angle. Basically, what they're asking you is for angle E2. Shh. Thank you, grade 10s. We're at the end. Right. What do we have? And they told us that this angle here is equal to X. So let's figure this out. So what do you see, guys? Okay, I see a whole lot of isosceles triangles. Do you see isosceles triangles? Right. That side is equal to that side. So angle E1 is equal to X. If that is X, that is X. Okay, what else do we have? What else do we have? It's a parallelogram. We know E2 is equal to R1. We know that angle P is equal to 180 minus 2x. Let's go. Come, guys. Let's work that. Come, take this one down. I want you guys to try. Apply your minds. Apply your minds. Apply your minds. If that angle is equal to x, that angle is equal to x. Let's see. This angle here will equal to 180 minus 2x, sum of angles of a triangle. Right. Let's see. What else do we have? What else do we have? What will angle S equal to? That's a parallelogram. Shh. So co-interior angles. So what is angle S equal to? I'm trying to fill out as many angles as we can. We got that angle to be X. Right. So I'm going to say angle E1. Wait. Let's go. Let's do it like this. Let's write it out. Angle PQ is equal to angle P, or line PQ, sorry. Line PQ is equal to line PE given. Therefore, triangle PQE is isosceles. Therefore, angle E1 equals X. Angles opposite the equal sides. Angles opposite the equal sides of an isosceles triangle. Therefore, angle P is equal to 180 minus x plus x, 180 minus 2x, and that is sum of angles of a triangle. Right, how much is angle S equal to? S is equal to 180 minus 180 minus 2x. Co-interior angles are supplementary. So angle S is 180 minus 180 plus 2x. 180 minus 180 is 0. So angle S is just equal to 2x. So angle S is equal to 2x. Shh. Ha, I see something. In this triangle here, that side is equal to that side. That's also an isosceles triangle. Wait. We're getting to our answer. How much time? Whoa, we're on 56. I promised you 58 and 30 seconds, 32 seconds. Hey, you guys got sharp memories. Right, let's go. Shh. Now, in triangle ESR, we know that ER is equal to SR given. Therefore, triangle ESR is isosceles. Therefore, angle E3 is equal to angle S, which is equal to 2x. The angles opposite the equal sides of an isosceles triangle. Quiet. Shh. So E3 is also 2x. This is an isosceles triangle. If that's 2x, that's 2x. Now I can find E2. We're coming to our answer now, and we're coming to the end of the program. Therefore, angles on a straight line add up to 180. Therefore, angle E2. Therefore, angle E2 plus x plus 2x is equal to 180. Angle E2 plus 3x is equal to 180. Angle E2 is equal to 180 minus 3x. Now this angle is 180 minus 3x. Right. How much is R in terms of x? Because if we can solve for x, guys, almost there. Almost there. I'm erasing here on this side. We need to solve for x, and then we can actually get the value of E2. So here goes. Now let's fill out everything. Let's see. Let's solve for x. Where can we get an equation to solve for x? See, if I found R2, but that we're going to get in terms of x. Then I find that. Then I add it. Then I can find R1. I'm just checking. You see, R1 plus R2 is 180 minus 2x, co-interior angles. Right. Angle R2 plus angle R1 is equal to 180 minus 2x, co-interior. Right. R1 plus R2 is equal to 180 minus 2x. But R2 in this triangle is equal to 180 minus 2x plus 2x. Sum of angles of a triangle. Sum of angles of a triangle. So R2 is equal to 180 minus 4x. So this angle is 180 minus 4x. So 180 minus 4x plus angle R1 is equal to 180. Wait, let's just do this. So R2 is 180 minus 4x. So 180 minus 4x plus R1 is equal to 180 minus 2x. Let's see. Shh. So 180 minus 180 is out. R1 is equal to minus 2x plus 4x. R1 is also 2x. Oh, I didn't need to do all of that because these two are alternate. That's 2x. That's x. Alternate. So E2. Right. All we need to do now is formulate an equation. We know that 2x plus 2x is equal to 360. Remember, this angle here is equal to that angle there. The opposite angles are equal. Opposite angles are equal. Right. Okay. I'm just going to write here, solve for x. Right. You can either use sum of angles of a triangle or you can use opposite angles. I know we've come to the end of the session. We have to cut off at 3 o'clock on the dot. How many minutes pass? 2 minutes pass. We are on 2 minutes pass. Okay, guys. We've come to the end of today's session. I think you guys need a nice round of applause. Solve for x and solve for angle E2. I just want to say Jazakallah. Thank you all for attending, guys. Thank you all for attending. Right, we're just going to have some concluding remarks here. Guys, you guys were amazing. Onliners, love to see you. Assalamu alaikum. Jazakallah for the 2 days of an amazing program. I hope you guys learned a lot. And we hope to see you in the future very soon. Havish, you'll be missed too. Farhan, Jazakallah. Here we go. Assalamu alaikum. Just some concluding remarks.
Thank you, Mr. Khota. This has been a phenomenal session. I'd really like to thank the learners of South Peninsula High. Give yourselves another round of applause. And
Well done. Well
let's
done.
give
Well
our
done. Walaikum
online
salam.
audience, they have also matched your enthusiasm. Give them a round of applause. Our
Yes,
online audience.
lovely, guys. Lovely.
So please use these videos. It's been loaded onto the Awqaf website, awqafsa.org.za, Maths Paper 1 and Maths Paper 2. We will see you again in August when we'll be hosting the next round for grade 10, as well as in October as we prepare you for your final examination. I would like to call on Mr. Baker. I think he's also got a few words to say in conclusion. But we're deeply appreciative for your time. You're spending your weekend over here and preparing for your examination. We pray and make dua and prayer that you excel. We need to get some 100%ers from here. We want to award you with some hard-earned cash. Mr. Khota is flying out to Johannesburg, so you will see him again in August. Mr. Baker, thank you so much for your effort, your staff, for your effort, really on behalf of the Awqaf team and the whole technical team. Would like to thank also the 216 team that's been behind the magic of some of the technical things here, Sami and co. Would like Baker, concluding remarks.
Wow, students, I'm sure you will agree with me. This was a solid sessions, which I'm sure you have all enjoyed. Let's give Mr. Khota and Hasnain a round of applause. And then students, for those of you who were here for both days, you've shown tenacity. You've shown perseverance. Those are, when you look at successful people today, those are the characters that defines him. Perseverance, that tenacity, that drive. And students, to all of you, to those of you who've been live streaming across the country, well done to all of you. And I want to say, students, I want to say this, that yes, many of you are tired, and I'm sure you want to get home and maybe just have a little bit of that Sunday lunch. You know, I'm sure your parent, mommy has set aside some lunch here for you. But I want to say, students, I want to say that you do have 6 other subjects also. Please see that you do your homework and have that homework ready for tomorrow. Also, students, it is a short week next week. Thursday is Ascension Day. So we need you here for the 4 remaining days. You need to be at school for the 4 remaining days. There's something else which Hasnain also brought to my attention. And often, you know, these long hours, it requires a lot of energy. And therefore, your diet is also important. I hope that the 2 sessions also gives you an indication of what FET is about. Grade 10, 11, and 12, that's FET. It requires a time management. It requires a lot of sacrifice that you need to make. You need to plan your weekends, plan your evenings to ensure that you are excelling in all your subjects. I also want to take this opportunity to thank the technical team for making sure that the live streaming, that reached all parts of South Africa. And the technical team for that. And then also I want to thank the educators at SP for being here for our students, Mr. Charles, Mr. Hendricks, and then also Mr. Samai and Mr. Idris. Those are the teachers who were here for the two sessions. So thank you very much to the teachers also. Students, hold it right there. Hold it. In fact, those students, could you go back to your seats? Back to your seats. Students, so without further ado, thank you very much to all of you for being here. And I see you at school tomorrow. Thank you.